Okay, welcome to this video where we're going to be having a look at all of the topics that haven't yet appeared on papers 1 and 2. Now, if you have been following along with my paper 1 and 2 videos, you will probably recognise a lot of these questions, as I have removed all of the questions and all of the topics that have already appeared on papers 1 and 2. As well as that, I have included more questions and more topics as well, but this video is going to be focusing exclusively on those topics that haven't appeared. So as I said, if you have followed along with the paper 1 and 2 videos, you will likely recognise quite a lot of these questions and topics, but these are all fantastic questions that were selected for these exams, so there's lots of questions and lots of topics to work through in this video. So with that being said, let's get started with this question. Okay, so looking at our first question on using a calculator. Now with using a calculator, we just need to make sure it looks exactly the same. So here we've used our fraction button, we've then typed in the cube root, and we're using our blank power button, making sure we come out of the power here before pressing the tan button. We don't need to put that degree symbol in. So onto the bottom of the fraction, 9 to the power of a half. Once we've typed it in and we're happy it looks exactly the same as it does on the paper, we'll press equals. This question wants us to round to 3 significant figures, so we'll chop after the 1 here, so that'll be 0.482 as our final answer. So just making sure it looks identical to however it does on the page. Okay, so if we are asked to find the highest common factor of two numbers, there are two methods that we can use. The first method is just looking at the factor pairs, and it is important to be able to find factor pairs for other aspects of topics. So if we look at the easier number to start with, you'll have to make a decision as to which one you think is the easier number. Typically it is the smaller number, or specifically if it ends in a 0, it tends to be quite a nice number to find the factors of. So for 60, we can have 1 times 60, 2 times 30, and of course you have a calculator for this, so we can then have 3 times 20. You can then grab your calculator and have a look at some other factors. You've got 4 times 15, 5 times 12, we have 6 times 10, and then you just need to test the numbers between 6 and 10. So we can go on the calculator, 60 divided by 7 doesn't work, 60 divided by 8 doesn't work, and then by 9 doesn't work. So they are all the factors. We then want to have a look from the highest number, thinking about which one of those factors goes into 84 perfectly. 60 doesn't, so you can kind of cross them off as you go. Remember, you just need to do 84 divided by this number now. So divided by 60, no, doesn't divide by 30, doesn't divide by 20, doesn't divide by 15, does divide by 12. So on your calculator, you can type it in if you want, but 84 divided by 12, you get the answer 7. So it's 7 times 12, but of course we're just looking for that highest common factor, and that is 12. So there we go, that would be our answer. Our highest common factor is 12. Now you can use your fact button, or you can write them as a product of prime factors. So if I do 60 as a product of prime factors, that comes out as 2 times 2 times 3 times 5. And you can do the same for 84. And 84, and again I'm just doing this on my calculator, but you can write it out as a product of prime factors as well. That comes out as 2 times 2 times 3 times 7. And if you are finding the highest common factor, we're just going to look at which factors appear in both. They both have a 2, they both have another 2, and they both have a 3. So whatever numbers are in both, we can just multiply those together. So 2 times 2 times 3, all on the calculator, comes out again as 12. So do two different methods there that you can use to work out the highest common factor, but there we go, that is the highest common factor. So looking at some product rule for counting. It says here there are 95 girls and 87 boys. One girl is going to be chosen for the role of head girl, and a different girl is going to be chosen for the role of deputy head girl. And then we have the same options for the boys. It says work out how many different ways this can be done. Now with the product rule for counting, and the hint is in the title for this, product means to multiply. So all we have to do is find the different options in each scenario, and we'll multiply them all together. So here we have one girl is going to be chosen, and that's out of 95 girls. Now a different girl is going to be chosen for head girl. So once the head girl's been chosen, the deputy head girl, there's only going to be 94 options. With the boys, there is 87 boys, and once the head boy has been chosen, there will only be 86 choices. Now, if we wanted to find the combination of the different girls that could be chosen, we'd just do 95 times 94. However, for each of those different combinations of girls, there is then one head boy which is going to be chosen, which means we need to multiply that by 87, and then there's 86 boys that could be chosen for the deputy head boy. So all we have to do is multiply all of these together, 95 times 94 times 87 times 86. We are going to get a very large number here, but our final answer is 668,14260. There we go, that is 66,814,260 different options. Now in this question we are looking at some standard form. If we need to convert numbers in standard form, it might be that if you type it into the calculator, it'll do it for you. So this particular number here, it comes out as a fraction, so if we convert that, this one on my calculator does come out in standard form. If it doesn't, you just write the number down, hop that decimal so it's between 1 and 10, and this one has a negative power as it's a 0-point number. For the next part of this question, we have quite a large sort of fraction to type in under this square root. We need to put these numbers that are in standard form into the fraction, being careful to put our negative power in, and then coming out of the top onto the bottom, and this one has d cubed on the bottom. So I'm going to put this one in brackets, 1.4 times 10 to the negative 4, and then once I close the bracket and make sure we come out of the power, then I can put my cubed in, and there we go, we have our power of 3, pressing equals, and we will get our answer. It does want this to 3 significant figures, so we'll write that down, drop it after the third number, so that'd be 4,520, and then we need to hop the decimal back in 3 jumps to make it 4.52, and that'll be times 10 to the power of 3. So we're looking at standard form. We've obviously got lots of different conversions that we can have. Now this one here is converting to an ordinary number, and we have a positive power. So when we have a positive power, we are going to make this into a large number. We're going to jump 5 places to the right. So 1, 2, 3, 4, 5. That's where the decimal will go. Filling in your zeros underneath the loops there, and normally then just rewriting that number nice and neatly. So 450,000 would be your final answer. It is always worth checking. If you type it into a calculator, does it give you that as an ordinary number? So if I type this one in, it does actually come up as 450,000. So don't forget you can use your calculator for these questions. For the next one, we have adding numbers in standard form. Now again, you may also be able to use your calculator for this. So if we type this in, 4.2 times 10 to the power of 3 plus 5.3 times 10 to the power of 2, that actually comes up straight away on my calculator as 4,730. And there we go, I get my answer straight away. Now, of course, if you didn't do that on a calculator, you could convert them both to ordinary numbers. So 4.2 would become 123, 4,200, and 5.3 would be 2 jumps, it's 10 to the power of 2, 530, and then you can just add those two together there. Now, this question does say to give your answer in standard form. So that's where this is sort of, a calculator-based topic, because we still have to convert it back, and my calculator doesn't give me 4,730 in standard form. So I do need to convert this back. It goes 1, 2, 3 jumps to make it between 1 and 10, and that would be 4.73, and then times 10, and it's 3 jumps, so 10 to the power of 3. And there we go, that would be my answer written there in standard form. Now, when looking at bounds, we do have a lot to type into a calculator. It's not overly complex to type this into the calculator, it's just getting those error intervals correct and using the correct bounds. So, when typing this into a calculator, it does look very similar to a previous question, so we won't use a calculator, well, we will use a calculator, but not on the screen for this one, as it's relatively nice to type in. So here, we have E is 6.8, correct to 1 decimal place, and using error intervals for that, E is therefore going to be between 6.85, adding that 5 on the end, and 6.75, and just dropping that down by 1 for the 8, and then sticking the 5 after it as well. For 0.05, not as nice actually to write the error interval for, but that's going to be 0.055 and 0.045. And there we go, there are our error intervals. It says here to work out the upper bound for the value of p. So to get the upper bound, which is the biggest possible answer, we want to have the biggest possible answer here on the top divided by the smallest on the bottom. So this will be the upper bound on the top and the lower bound on the bottom. So E, we want to use our biggest possible number. So for E, we're going to use 6.85. And for F, we want the smallest possible answer, so 0.045. So all we need to do is type that into our calculator. So we're going to do the square root of 2 times 6.85. And on the bottom, we're going to do 0.045. Once we've typed that in, it does want us to give our answer to 3 significant figures, but if we type that into the calculator, 2 times 6.85 on the top and 0.045 on the bottom, making sure it's all underneath the square root, we get a final answer which comes out as 17.448336644. I've written the whole number down. Now I'm going to round it to 3 significant figures, which is just after the 4 there. So that comes out as 17.4, and that is our upper bound. Now again, if we were asked to work out the lower bound here, then you would put the smaller number, or the smaller or the lower bound of E on the top, and the upper bound of F on the bottom. If we were asked to consider bounds, then we'd actually work both of them out and see if they round the same. So just read the language very carefully in these questions. But there we go. This one just wanted us to find the upper bound. Okay, so looking at some expanding and factorising. Now here we have 2 sets of single brackets to expand. We just need to be really careful on this one as we have got a subtraction there in the middle. So for the first bracket, we have a nice expansion, just multiplying those by 5. So that'd be 5p plus, and then we have 15. Now for the second bracket, there are 2 ways to approach this. We can either multiply everything in the bracket by 2, and then remember to subtract them, which just means we have to think a little bit more carefully, as there is a negative 2p there. When we're subtracting a negative, it will turn into a positive. So you just need to be really careful. Now I prefer to just multiply by negative 2 straight away. Then I don't have to think about that process later on. So negative 2 times 1 is minus 2. And negative 2 times negative 2p would be positive 4p. And now we can collect those like terms together. So we have 5p, add 4p, so in total we are going to have 9p. And then we also have the 15 here, take away 2, which leaves us with 13, so that's plus 13 in total. And there we go, we get 9p plus 13. Now this next part here is a little bit of a strange quadratic. We have a squared minus b squared. We're being asked to factorise that. Now this is very similar to a difference of 2 squares, a normal quadratic that we would see, something like x squared minus 16. And hopefully if you saw that one, you would know that that is x plus 4 and x minus 4 in the brackets. Now this is exactly the same above. It's a difference of 2 squares. It's just a squared and b squared. So we'll factorise this in the same way. We'll have a plus b and a minus b. And there we go, that's factorised. And if you were to expand that, you get a squared, then you get minus ab plus ab, and they cancel each other out, and then the minus b squared. It says hence or otherwise, simplify fully, and then it's given us basically the same thing, except there's loads of pieces in the bracket. Now this here, we have this x squared plus 4, that's just our a. And then we have this x squared minus 2, and that would be our b. So all we need to do is replace the a's and b's in our previous answer, the a plus b, a minus b, with these new pieces. So if we start with the a plus b, well, a is x squared plus 4, so x squared plus 4, and then we're adding b to that, so adding x squared minus 2, and that's our first bracket done. And in the second bracket, it's a minus b, so x squared plus 4, and here's where you've got to be really careful because we are subtracting b, so minus the x squared, and then we're going to subtract the negative 2. So we're looking at this piece here now, this subtraction of that negative 2, and that would be plus 2. So if we simplify what we have in the brackets, on the left bracket, we have 2x squared, 4 and minus 2 makes plus 2, and that's our first bracket. The second bracket, if we simplify what's in there, we have x squared minus x squared, so that's gone completely. and then the 4 plus 2, which just leaves us with 6. Now normally if we had something written like that, of course we would write that as a single bracket, 6 lots of 2x squared plus 2. And we do want to simplify this. There's two things we could do. We could either expand that, which would give us 12x squared plus 12, or we could go ahead and refactorise it and fully factorise it, in which case we could put 12 on the outside and you could have x squared plus 1 on the inside. Now either one of those answers would be fine. I would probably just leave my answer as 12x squared plus 12. It doesn't say it needs to be given factorised, it just says it needs to be simplified. But there we go, there's some expanding and factorising. Okay, so on to some algebraic fractions. Now in this one we are dividing algebraic fractions. When we are dividing algebraic fractions, we just need to multiply by the reciprocal. So keeping the first one as it is, flipping the second one over, we're going to times them instead. It does say it can be written in a particular form, so we need to be aware of that and just be really careful as we go. But let's have a look at the first fraction. Now the first fraction just has 6x cubed on the top, so that can stay as it is. The denominator here does have a difference of 2 squares. So 9x squared minus 144, 9 and 144 are both square numbers, so that would factorise to 3x plus 12 and 3x minus 12. There we go, just the square root of 9 and the square root of 144 in those sort of replicated brackets where one's a plus and one's a minus. Now it's up to you, we can factorise the second one if it needs factorising. This particular one doesn't look like it actually needs factorising, so we can just flip this over and start to get to a point where we can start to think about multiplying them. So we have 2x to the power of 4 on the bottom and 3 lots of x minus 4 on the top. Now from this point we are kind of looking now to see if anything can actually factorise or cancel off or anything at all. So at the moment you can see that there is a 2x to the power of 4 on the bottom right and a 6x to the power of 3 on the top left. Now we can actually divide both of those by 2 and both of those by the x to the power of 3. So we can cancel those down. If you want to write that in one step, we could say, well, divide the top here by 2x to the power of 3, and we'll divide the bottom here by 2x to the power of 3. Now looking at the bottom left fraction of the fraction and the top right of the right fraction, there's nothing actually at the moment that simplifies there. However, if we expand this bracket, we get 3x minus 12, and that does match one of the brackets on the bottom left on the left fraction. So they're going to cancel off as well. So actually we can divide by 3x minus 12. That's going to cancel off this numerator here. When we divide by 3x minus 12, as there's only 3x minus 12 there, that will just turn into 1. And this 3x minus 12 here will disappear. So that's all the kind of thought process as to what we can cancel off to start with. So we need to write what we've actually got left once we do that. And we'll still keep it as two fractions for the moment. So here, 6x to the power of 3 divided by 2x to the power of 3, well that fits in 3 times. So we have 3 as our numerator. On the bottom, we just have that 3x plus 12 as the 3x minus 12 has now cancelled off. We don't need to keep it in brackets anymore because there's nothing else with it. We're going to multiply that, and on the right fraction we have 1 on the top as we've cancelled off that 3x minus 12, and on the bottom we have 2x to the power of 4 divided by 2x to the power of 3. Well, that just is x, as it's x that you have to times by 2x cubed to get to 2x to the power of 4. So that's what we're left with. We now just need to expand this, or expand the brackets on the top and the bottom. Now on the numerator, it's 1 times 3, so no bracket there, just 3. On the denominator, it's x multiplied by 3x plus 12. So that'll give us 3x squared plus 12x. Now we're kind of getting there, but this does want it in a particular form. It wants it to be 1 on the top. Now if it wants it to be 1 on the top, that means that the numerator and denominator must divide by 3. And you can see that that denominator does factorise by 3. So we could factorise the bottom by 3, so we can cancel these 3's off, and that would leave us with x squared plus 4x. Now we can actually cancel off the 3's. We will get 1 on the top now when we divide by 3. So if we rewrite that, let's see what it looks like. We have 1 on the top, and we have this x squared plus 4x on the bottom. Now we are almost finished. It does say in the question it wants it in the form on the denominator here, x brackets x plus r. So we just need to factorise x out of the denominator. We've still got 1 on the top, which is what we wanted. On the bottom we'll have x lots of, x times x makes the x squared, and x times 4 makes the 4x. And there we go. R, or the value of r, is 4, and we've got it in that form that it was asking for. There you go, quite a complex algebraic fraction there, but lots of steps in terms of how to cancel or cross-cancelling in the start, and also cancelling by factorising. And this was quite an interesting one because we actually had to expand the numerator on that right fraction in order to cancel off those common factors. So there we go, a nice interesting algebraic fraction question. For this next algebraic fraction, we are adding or subtracting. In this particular one, we are actually subtracting here. It says show that, and then we have a big calculation to work out. But it says show that it can be written in the form ax plus b over x squared minus 4, where a and b are integers. Now when we are adding and subtracting, the same as just with normal numbers, we do that from left to right. So here we're going to first subtract these two fractions, and then we will deal with that subtraction of 1. So let's just start by doing those. Now we need a common denominator in order to subtract these. So that means we need to multiply this left fraction by x minus 2 and this right one by x plus 2, and that's on the top and the bottom. So if we write that out in sort of a long form, we have 3x multiplied by x minus 2 on my numerator, and that's now over x plus 2 and x minus 2. On the next fraction, we have 2x plus 1 multiplied by the x plus 2, and that's all over the same denominator, x plus 2 and x minus 2. And there we go. So let's just look at expanding these and sort of tidying it all up and just seeing what it looks like, and then we'll think about that one. So for this first fraction, 3x times x and 3x times minus 2. 3x times x is 3x squared, and 3x times minus 2 is minus 6x. The denominator, x plus 2 and x minus 2, we can expand that because it does want it in an expanded form. It says here x squared minus 4. And actually that is a difference of 2 squares anyway, so it does just become x squared minus 4. You can take your time to expand that if you want, but you'll see those two middle pieces cancel out. We need to subtract from that then. Our next one, we already have the denominator, so we can write the x squared minus 4 on the bottom. We just need to expand these double brackets. So 2x times x gives us 2x squared. And to save myself actually too much working out here, I'd probably expand this just to the side so that I can tidy it up and put it straight on the numerator, so I don't have to keep writing this out. So we've got the 2x squared. 2x times 2 is going to be 4x. Then 1 times x plus 1x. And 1 times 2 is plus 2. So we just want to join these middle pieces together. That'll be 5x, so we can write that on the numerator now, plus 5x plus 2. Now we do have to subtract these fractions, so I need to be really careful, because when I subtract the 2x squared, I'm going to be taking that away. I'm going to be subtracting the positive 5x. I'm going to be subtracting the 2. Looking at this numerator up here and being really careful with that. So we have 3x squared on the numerator, take away 2x squared. That leaves us with x squared. We have negative 6x, take away 5x, that's minus 11x. And then we have nothing, take away 2, so minus 2. And that's all over x squared minus 4. So that is the first two fractions combined. We've already done an awful lot of work just to get to this point. But now I need to take away 1. Now, with a whole number, I want to write that as a fraction. So I'm going to write that as minus 1 over 1, which seems a little bit strange to do, but we need a common denominator. Now, our common denominator that we're going to need is x squared minus 4. So I'm going to multiply both sides, well, top and bottom, by x squared minus 4. As it is just 1, it is actually relatively nice. They both just come out as x squared minus 4. So if I write that out so I can deal with this subtraction, on the left we have x squared minus 11x minus 2 all over x squared minus 4, and the right fraction is going to be x squared minus 4 over x squared minus 4. And again, being really careful here because we do have that subtraction again. So when we subtract these, we are going to just need to be really, really careful with those positive and negative symbols. Let's just move this out of the way so we have some space. So what do we get? Well, x squared, take away the x squared. So just looking at these two to start with, they actually cancel out. So they're gone completely. So we have minus 11x, take away, and there's no x's there, so that'll be minus 11x. We have minus 2, take away minus 4. So when we take away negative 4, that's going to add 4. We're starting on negative 2. Again, you can use a calculator for this, but that's going to become plus 2. And then on the denominator, we have x squared minus 4. And there we go, we've joined it all up. Now, normally I would write that as 2 take away 11x on the numerator, but it wants it in the form ax plus b, so we'll leave it in that form there, minus 11x plus 2 all over x squared minus 4. Obviously a very large question there, lots to think about, lots of positives and negatives to be careful of. You can always use your calculator at any point for those positives and negatives, of course, if you're doing a calculator paper. But there we go, there was some adding or subtracting algebraic fractions. Okay, so looking at some algebraic proof, this question says prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. Now, when we are looking at an even number, we will use the algebraic expression 2n. When looking at an odd number, you can either use the positive or negative version of this, but all we need to do is add 1 to the even number. So for the first odd number, we'll have 2n plus 1. The next odd number, we would add 2 to that, thinking about a number line. You add 2 to get between the odd numbers. So the next one would be 2n plus 3. Now it wants you to find the difference between the squares of these. So the squares of them, we would put them in brackets and square them, which is going to mean we've got 2 lots of double brackets to do. But we need to be really careful here because when you are finding the difference between two things, we want to do the bigger take away the smaller. So the 2n plus 3 is the bigger odd number, so we would want to put that first and then put a subtraction between them. So there we go, we want 2n plus 3 squared take away 2n plus 1 squared. So we want to take our time expanding these. So for the 2n plus 3, we would get 4n squared plus, and maybe expand it to the side, but I would like to do it all in one go. 2n times 3 will be 6n. We've got 2 of those, so we would have plus 12n, and then plus 9. If you don't like expanding a double bracket in one step like that, then obviously just write 2 brackets to the side, 2n plus 3, and 2n plus 3, and just take your time to expand them, and just make sure you get that expression correct. We are then going to subtract the next one, and again, you just write out 2n plus 1 and another 2n plus 1, and that gives us 4n squared plus 2n, so plus 4n, and then 1 times 1 gives us 1. Now, because of this subtraction, because we are finding the difference between them, we have another scenario where we need to be really careful, because we're actually taking away all of these. So I'm going to put that into a bracket just so I don't forget that all of those 3 pieces are being subtracted from the first 3. So we have 4n squared take away 4n squared. Well, actually they just cancel out, so they disappear. We don't need to worry about the n squareds. We then have 12n take away 4n, so that leaves us with 8n. That's a good sign because it did want us to show that it's always a multiple of 8, and anything times 8 is going to be a multiple of 8. And then we have plus 9 and take away the 1. 9 take away 1 leaves us with 8. So there we go. We're definitely in a good position here. It wanted us to show that something's always a multiple of 8. Now at this point you could actually write a description here which says why that's always a multiple of 8, because if you times any number by 8, it's in the 8 times table, and if you add 8 to that, it's still in the 8 times table. However, a really good process at this point is to factorise by that number that we want to show it's a multiple of. So if we take a factor of 8 out, you get 1n plus 1. And there we go, this 8 on the outside here shows that any number that you put into that bracket, it's always going to be something multiplied by 8, and therefore it's always a multiple of 8. You can write some words along with that if you feel happy to do so, however you can just leave it with this algebraic proof as well. I do like to just add some words and just point at the 8 and just say anything times 8 is always a multiple of 8. So we've got some changing the subject here where we have roots and powers involved. It says here to make k the subject of the formula. Now, if everything is underneath a square root or a cube root, the first thing we need to do is to unlock what's underneath by getting rid of the root. The way to get rid of a square root is to square both sides. So the first step is relatively nice because if we square both sides, well, the left side would become m squared, and the right side here, we were just getting rid of that square root. So we're just going to write what's underneath it, k cubed plus 1 all over 4. We now have a fraction, which is stopping us from moving pieces on the numerator. So to get rid of the fraction, we're going to need to multiply by 4, as that obviously means dividing by 4 on the bottom. That's going to remove this divide by 4. And then on the left, we will have 4m squared now. And that's now equal to k cubed plus 1. Now at this point, you've got two options. We could cube root, however I do like to do the powers last there, as normally you do powers first when you're going forwards, but we are doing the inverse. But you just need to remember you'd have to cube root everything. So instead of doing that and forgetting to cube root things, I'm going to subtract this 1, and that will leave me with 4m squared minus 1 is equal to k cubed. We can now think about removing that cube by cube rooting both sides. If we cube root the left now, we get the cube root of 4m squared minus 1, and that is now equal to k. And you can write that the other way around if you want. You can write k is equal to, and it might say k equals on your dotted line, k equals the cube root of 4m squared minus 1. And on to some changing the subject with factorising. So it doesn't tell us in the question we're going to need to factorise, but the big hint that we've got a more difficult version here is the fact that there is an a in two places, and that's what it wants us to make the subject. So we have an a here and an a there. So it's not sufficient just to minus the 3 and then have it as a equals because there's another a on the other side of the equal sign. So we need to get all the a's on the same side. To do that, we're going to need to unlock the right-hand side by multiplying by r. So the first thing I'm going to do is multiply by r, and that's going to give us ar plus 3r on the left-hand side. We'll then just have this 2a plus 7 on the right. Now we want the a's on the same side of this equal sign, so it's up to you. You can either move them to the left, or you can put all the a's on the right. I tend to prefer to move them to the left, but always just look at the symbols and see if it's going to create any additional negatives anywhere, or if we can remove negatives by moving to the other side. Now in this case, we have plus symbols on both sides, so it doesn't really matter, so I'm going to minus 2a to the other side. Now we also need to minus 3r. You can do that in one jump if you're happy doing so, but I'm going to move it in 2 steps. So I'm going to do ar minus 2a, and then we have the plus 3r, and that's equal to 7. Now I'm going to minus this 3r, so we have the a's on their own, and that's going to make it ar minus 2a is equal to 7 minus 3r. And of course this would look slightly different if we move the a's to the right. Now at this point we can factorise the left, we can factorise the a out of the bracket, which will leave us with r minus 2 inside the bracket, and then we have that is equal to 7 minus 3r. At this point, the final step is to divide by this bracket. That's going to isolate the a and leave it as a equals, and then as we are dividing by that whole bracket, we need to create a fraction. So we have 7 minus 3r all over, and it's up to you at this point. You can leave it in the bracket or you can remove the bracket, but we have r minus 2, and there we go, and that would be our final answer. A is now the subject, and a does not appear anywhere else within this. So there we go, that is changing the subject with some factorising. Okay, so in this question we're having a look at some algebraic proof. However, in this type of algebraic proof here, we are manipulating an expression to try and make it create this even number that it's asking for this proof here. So here it says n is an integer greater than 1. Prove algebraically that n squared minus n minus, and then we've got in brackets n minus 2 squared, and showing that it's always an even number. So here, to start with, we need to get rid of these brackets. So we need to expand this, and not forgetting that that is a double bracket. So I'm going to do this bit to the side. We have n minus 2, and another n minus 2. And if we expand that bracket, we have n times n, which is n squared. We then have n times negative 2, which is minus 2n. We then have negative 2 times n, which is another minus 2n. And then we also have negative 2 times a negative 2. And a negative times a negative makes plus 4. We do want to simplify this before we put it back into that original expression that we have there. So we have n squared minus 4n's in total and plus 4. Now all I'm going to do is rewrite what we had, except I'm going to now replace that squared bracket with this new expression n squared minus 4n plus 4. So when we write this, we have n squared, take away 2, and then here's where we need to be careful, because it's now asking us to subtract anything that we had there. Now, if we just write this expression, n squared minus 4n plus 4, we might fall into the trap of only subtracting the n squared, but it's asking us to subtract everything there. So to be safe, the best thing to do is to put this whole thing into brackets, just like it was originally. That's going to remind us now to subtract the n squared, to also subtract the negative 4n, and to subtract the positive 4. Now, some of those are going to be a little bit strange to subtract because we don't actually have any n pieces on the outside of the bracket, we just have the n squared. But if we have a look, we have the n squared minus an n squared. That's actually just going to disappear. So these are just going to kind of cancel each other out. So that's actually dealt with. We have, and now it kind of feels a bit strange because we're going to subtract negative 4n, but there's no n pieces on the outside of the bracket. So if we're going to do that, we are essentially subtracting negative 4n from nothing, but when we subtract a negative, it does add 4n. So we have 0, add 4n, which just makes positive 4n. So we have ended up with something from that, but it feels a little bit strange, subtracting a negative 4n from nothing. But there we go, that is our n pieces. We now have the number to deal with. We do have a minus 2 here, and we're going to subtract this positive 4. So negative 2 subtract 4 would get us down to negative 6. And that is our final expression there. But you might just want to have a look at that again, because it is a little bit strange when we're doing this. We had n squared take away n squared, so they cancelled each other out. That was quite a nice part, that's done. We had nothing, no n's, take away negative 4n. So no n's, add 4n, got us to 4n. And then we had the negative 2 taking away the positive 4. Negative 2 take away 4 is negative 6. So we have our final expression. Now to prove that this is always an even number, we want to prove that it's always going to be in the 2 times table. Now the best way to do that is to factorise 2 out. So if we take 2 out of the bracket, we would have 2n, and then we would have minus 3. And there we go, we can close the bracket. Now in this, we could write, just next to this, anything multiplied by 2 is going to be an even number. So anything that we pick for n will be multiplied by 2, and therefore it will be even. And there we go. I'm just going to write even next to this, but you could write a full description next to that. But there we go, there is some algebraic proof. Okay, so our next question, we have some functions. Now this particular function also has fractions within it, and we have quite a difficult part C to this. Now part A says work out the function of 5. So if we're going to put 5 in, it needs to go in all the positions where we have an x. So here we're going to have a 5 on the bottom of this fraction, and we're going to have a 5 on the bottom of this fraction. So if we actually sub that in, we have 1 over 5 plus 2, which is 7, plus 1 over 5 take away 3, which is 2. So we have 1 over 7 plus 1 over 2. We just need to make sure that we make a common denominator here. So when we are dealing with fractions, we want 14 on the bottom, so timesing the left fraction by 2 and the right fraction by 7. Now, of course, we are doing this as some calculator practice, so we can actually just type this in on the calculator. 1 over 7 plus, and then 1 over 2, typing that in on your calculator gives you 9 over 14. So there we go, our final answer is 9 over 14. For part B here, it says write down a value of x for which the function of x is not defined. Now, when we are dealing with functions, and specifically where we have divisions, we cannot divide by 0. So there are some values of x here which would leave a divide by 0 within one of these fractions. So looking at this fraction here, well, this value of x, we are adding 2 to that. So what number could you put there that when you add 2 makes 0? I'm not trying to trick you here, it is just negative 2. Negative 2 add 2 is 0, so we can't have negative 2. Over here, which value of x would make that become 0? Well, it's something take away 3, and that would be 3. 3 take away 3 is 0, and again that would cause a division by 0. So neither of those numbers are allowed. It does say write down a value, so we don't have to give both. We would either write negative 2 or 3. So you just pick one of those and we'd give either of them. For the next part here, it says given that the function of x is equal to 4, find the possible values of x and give your answer in the form p plus and minus root q over r, where p, q and r are positive integers. Now, it says that f of x is equal to 4, or in other words, this whole function, 1 over x plus 2, add 1 over x minus 3 is equal to 4. So what we actually have is an algebraic fraction equation that we need to solve. Now to do this, we do need a common denominator, and there's a lot of steps to this particular part of the question. So for our common denominator, we would have to multiply the left fraction by x minus 3, and we would have to multiply this right fraction by x plus 2, and that's on the numerator and denominator. The nice part here though is that the numerators are only 1, so that's going to make it a little bit less work, but that means we have x minus 3 on the top. On the denominator there, we are going to get a double bracket. You could expand that now or expand it later. I'm going to expand it now, so just doing an expansion to the side, we have x plus 2 and x minus 3 that we need to expand. So x times x is x squared. We then have minus 3x and plus 2x, that's minus 1x. And then 2 times negative 3 is minus 6. For the right fraction, we're timesing that by x plus 2, which just gives us the x plus 2 on the numerator there. And then we have this quadratic on the bottom, minus x minus 6. Now ordinarily, I wouldn't even bother expanding the denominator, but we are solving an equation now, which means we need to join this up. We're going to be moving pieces around, so it is best to have that expanded. Now if we add together the numerators, we have x plus x, which is 2x, and negative 3 add 2, which is negative 1. Our denominator is still the x squared minus x minus 6, and that is equal to 4. So from this point now, we can move that denominator to the other side, which will introduce a bracket here. We'll have x squared minus x minus 6, and that will get rid of our denominator when we multiply that to the other side. If we do that in one step here, we've got 2x minus 1 is equal to 4x squared minus 4x minus 24. Now we want that to say equals 0, or we can have 0 equals. Now it's probably easier if we move all the pieces to the right hand side, so we can subtract 2x and add 1. And if we do that, we'll take away the 2x from this negative 4x, and we'll add 1 to this negative 24. That's going to leave us with 0 equals, and we get 4x squared minus 6x minus 23. We now have a quadratic that we can solve. However, it does want it in this form p plus and minus root q over r, which is essentially putting it into the quadratic formula. So here, A is equal to 4, B is equal to -6, and C is equal to -23. Our quadratic formula is minus b. We're kind of running out of space here, but it's minus b plus and minus the square root of b squared minus 4ac all over 2a. So if we put it into the quadratic formula, we will have minus b becomes 6 plus and minus. We then have the square root of, and as we're using a calculator, we could type this all in one go. So we have -6 squared, which is best to put into brackets. So -6 in brackets, squared on the outside of the bracket, minus 4 times a, which is 4, times c, which is -23. And if I press equals, that comes out as 404. We now have 2a on the bottom. So 2a is 2 lots of 4. So we will have 8 on the bottom. Now at this point we do have our answer in the form that we've been asked. So that is a final answer that we could give there, 6 plus and minus the square root of 404 all over 8. However, this is a calculator practice question and you could type that into your calculator and it does come out as 3 plus and minus. When you type it into your calculator you can only type in the plus or the minus, but it comes out as the square root of 101 all over 4. So either of those answers are fine. If we do put it in a calculator, this is the final answer that we will get, but we have given it in that form. So you could type it in all in one go into the quadratic formula and it actually would have come out in that form straight away. But there we go, we've got our answer in the form that it was looking for, 3 plus and minus the square root of 101 all over 4. And looking at some more functions, this one here, we've got the function of f is 4x minus 1, and it wants us to find the inverse function of f. Now when I'm finding the inverse, I swap this f of x for y equals, and then I just need to make x the subject. So to make x the subject here, we would add 1 to both sides, which gives me y plus 1 is equal to 4x, and then I just need to divide by 4. So if I divide by 4, we get y plus 1 divided by 4 is equal to x. Now at this point, normally on your dotted line, you would have f to the minus 1 of x equals, and then dot, 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 dot. So before we put that fraction in, we just need to swap the y back for an x, and our function would be x plus 1 over 4. And there we go, that's an inverse function. It says in this next part, the function of g is such that g of x is equal to kx squared, where k is a constant. It's not told us what k is. It's also hinted here that it's not a whole number by saying it's a constant. Given that fg2 is equal to 12, work out the value of k. So we have a composite function here, but the function of g has this kx squared. We need to put the function of g into the function of f. So normally I would just put a bracket around this, a bracket around the x in the other function, and just replace that piece. So we have 4 lots of kx squared minus 1. And there we go, that is the function fg. It does want us to put 2 into that, and it says that it's equal to 12. But let's first just expand this. So we have 4kx squared, or x squared k, however you prefer to write it, minus 1. And now it wants us to put 2 into that function. Now 2 goes in place of the x, and 2 squared is equal to 4. So we have 4 times k times 4. Well, let's just do the 4 times 4, so that would be 16k minus 1. And it tells us that that is equal to 12. So it's equal to 12, so we would write equals 12. And now we have an equation that we can solve. So solving this equation, we would add 1 to both sides. 16k is equal to 13, and then divide by 16. K is equal to 13 divided by 16. And there we go, that's the value of k. And as you can see, it's 13 over 16. It's not a whole number. And there we go, that word constant sometimes gives us a hint. It doesn't mean it's not a whole number, but if it was a whole number, it's more likely they would say where k is an integer. But there we go, k is equal to 13 over 16. Okay, so looking at solving quadratics using the quadratic formula. Now when you're on a calculator paper, even if a quadratic does factorise, it doesn't mean that we can't use the quadratic formula. So here the first thing we want to do is we want to label the values of a, b and c. So A is 6, B is 5, and C is negative 6. We can write down the quadratic formula and start typing it into our calculator. So I tend to start by starting with the plus symbol. Doesn't actually matter, but we'll start with the plus symbol here and putting that B value in brackets. So we have 5 squared here. We're going to take away 4 lots of A, which is 6, and C, which is negative 6. And then on the bottom we have 2 times A, so 2 times 6 on the bottom. We can press equals and we'll get our first solution here. We can write that down as a fraction, or we can convert it into a decimal. Just be careful, this one is recurring. And then we can start looking at the negative version. So we want to go back into our calculator rather than typing it all in again, and just go all the way back to that plus symbol. We're going to delete the plus symbol, put in that subtraction, and then press equals again. We get our second solution there, which is negative 3 over 2. Or of course, you can write that as a decimal. And there we go, that's the quadratic formula. Okay, so in this question we have a quadratic simultaneous equation. We do have quite an extensive one in this particular question. So we're going to use the substitution method, but you can see our second equation there, we have a 3x and a 4y. So we want to rearrange that formula so it's either x equals or y equals, which does mean we're going to have fractions involved in this one. Now, it's better here, I think personally, to make it x equals, and that's purely because we have a 1x squared here, and that's just going to avoid multiplying it by 4 as well once we've sort of squared it and subbed it in, but it doesn't actually matter either way. Now, I'm just going to opt for making it x equals. So I'm going to rearrange this formula to start with so that we have our x equals formula. So to do that, I need to minus the 4y. So we have 3x will be equal to 7 minus 4y. And then divide by 3. We get x is equal to 7 minus 4y, all divided by 3. I can now substitute that into that first equation. However, it is x squared, so I need to work out what that is squared. So x squared is first going to be equal to 7 minus 4y all over 3 squared. Now that means we're going to have a double bracket on the numerator. The denominator is nice and easy, 3 times 3 is 9, but I do have a double bracket I need to expand. So I need to get that out of the way first, just to avoid huge amounts of working out written over and over again. So if we expand this double bracket, we have 7 times 7, which is 49, 7 times negative 4y, which is minus 28y, we get minus 28y again, and then plus 16y squared. Now if I just reorder that and write it into a normal quadratic format, we have 16y squared minus 56y plus 49. And there we go, there's our numerator. Now on the bottom, 3 times 3 is 9, but we can put that now all into this first equation. So we have 16y squared minus 56y plus 49 all over 9, and then we have minus 4y squared is equal to 9. Now in order to get this equal to 0 and into a format that we are used to, we do need to get rid of this fraction, so I need to times by 9, which will get rid of this divide by 9. I just need to remember as well, this is also multiplied by 9, and so is this number at the end. So I need to multiply everything by 9 essentially. Now when we do that, we have 16y squared minus 56y plus 49. The fraction is now gone. And we have minus 36y squared in place of that 4y squared. And 9 times 9 is equal to 81. Now I want this to equal 0. It now does only have y's in it. I can definitely solve it. I need to minus 81 and I need to combine these y squareds. 16y squared take away 36y squared would give me minus 20y squared. So I've got minus 56y, and I need to do 49 take away 81. Of course, we can just do this on the calculator. That gives me minus 32, and that's now equal to 0, and it can be solved. Now at this point, I can just write down the values of a, b, and c and put it into the quadratic formula. However, I can see that these numbers divide by 4, so just to make the numbers a little bit nicer, I'm going to divide them all by 4, and that gives me minus 5y squared minus 14y. Again, you can just type this in on the calculator, and then minus 8 is equal to 0. I do just have some slightly nicer values of a, b, and c now to use in the quadratic formula. So a is equal to negative 5, B is equal to negative 14 and C is equal to negative 8. I need to remember my quadratic formula, but now I just need to put the values in the correct place and just being careful as we type them in. And obviously we just looked at the quadratic formula, so we won't pop the calculator up for this one. We have minus B, B is negative, so that'd be 14, plus and minus the square root of, we've got negative 14, so making sure that's in a bracket, squared, minus 4 times negative 5 times negative 8. There we go, we'll have to extend our square root there. And that's all over 2a. A is negative 5, so 2 times negative 5. Now I need to type that in once using the plus symbol, and if we type that in for the positive, and I just like to label that the fact that I've used the plus sign, when we use the plus sign we get y is equal to negative 2. And when I use the negative symbol, so go back into the calculator, delete the plus, put in a minus, we get y is equal to negative either 4/5 or 0.8. I'm going to leave it as a decimal, so y is equal to negative 0.8. So there's our two y values. I now just need to find the x values. Now I've got two that I need to find, and our equation for x is up here. So to get x, it's 7 take away 4y, all divided by 3. Now again, I'm just going to be typing this in the calculator, so we'll start with the negative 2. So we'll have x will be equal to, let's have a look, x is going to equal 7 take away, it's 4y, so 4 times negative 2, all over 3. And in that circumstance there, we get x is equal to 5. And for the next one, we have x is equal to 7 take away 4 lots of negative 0.8. Again, all divided by 3. And that gives us x is equal to either a fraction 17 over 5, you could write it as a mixed number as well, or the decimal is 3.4. So there we go, we have lots of numbers that we need to write down as our solutions. We have y is equal to negative 2, and in that scenario, x was equal to 5. And we also have y is equal to negative 0.8, and in that scenario, x was equal to 3.4. So a very complex quadratic simultaneous equation. Even just looking at all that writing, there is a huge amount there, so it's really important to keep this incredibly neat and tidy and ordered when you are doing this on the page. But there you go, there is a pretty tricky quadratic simultaneous equation. Now in this question, we are identifying a cubic and a reciprocal graph. Now this kind of question here does just rely on you sort of knowing what the graphs actually look like. However, if you for some reason have forgotten what they look like, you could substitute some numbers into your calculator. So you could sort of imagine you've got the negative 1 over on the left of an axis, negative 1 here, and you've got a positive 1 over here. So you could substitute the numbers negative 1, 0 and 1 into a calculator, into some of these equations, and see if it kind of matches up. However, it's not a perfect method, and there might be some questions where those numbers actually sort of kind of look very similar. You can see on this graph on the right here, it might be, and I'm not sort of scaling it or saying this is exactly where it's going to be, but you can see this is in the positive region, and you've also got numbers here that are in the positive region on that cubic graph. So it might just throw you a little bit. So it's not a perfect method. So the best method for this type of topic is just to sort of make sure you've plotted lots of these different types of graphs. Now we have different types of graphs here. Graph number A is a quadratic graph, and hopefully one that you recognise, and that's when you have an x squared in. So I'm going to use a sort of process of elimination method. So I know that that's an x squared. You might know different ones, but I know that's an x squared, so I know it can't be A. I also know that graph E is a straight line graph, which would be in the form y equals mx plus c. And with a positive y-intercept there and a positive gradient, maybe an example could be something like y is equal to, and let's just go with 2x plus 3, something like that. Just an example of what that could look like. But it wouldn't have a fraction in, and it wouldn't have a cubed in, so it's not this one. Now that only leaves us with a few graphs here. We have two cubic graphs. We have graph B and graph F. So both of those could be a graph that has an x cubed in. Now both of those also have a y-intercept at the origin, at 0. And you can see there's no number at the end of our x cubed graph. A good giveaway would be if it said x cubed plus 3, because we'd know it'd have to cross through 3 on the y-axis. However, neither of these have them. Now this is just about recognising the graph. Now the graph of x cubed is actually graph f. So f is the answer for this one. The graph of x cubed that we can see in graph B has some additional elements added into the equation. It might be that it's y is equal to x cubed, maybe also plus an x squared, I don't know, plus 5. Could be anything in there, but it's got extra things with the x cubed. And that's what happens in terms of the graph. It makes additional points where it crosses through the x-axis. The graph of x cubed on its own just has this one, what I'll call a squiggle, that sort of squiggles up, goes through the origin, and then continues going up. So that's our graph of x cubed. We then have two reciprocal graphs. So for graph D and graph C, we have a reciprocal. Now if you think about the fraction 1 over x, everything is positive within that fraction. The negative version would be y is equal to negative 1 over x. Or you could put the negative on the top or the bottom of the fraction. Now if we look at this graph, there is one where the graph is drawn in the positive quadrant. And the positive quadrant being this particular region just here, where the x coordinates and the y coordinates are both positive. And that means that that is graph D. The negative reciprocal, which I've drawn below, y is equal to minus 1 over x, well, that is graph C up here, where we have y is equal to minus 1 over x. So it's a bit of a strange topic because it does rely on you already knowing what they look like. And if you already know what they look like, it's a relatively easy topic. So it might just be that this is something that you sort of draw the different graphs on a revision card, and just remember if you see them that you already know what they're going to look like. You have your straight line graph, which can have a positive or a negative gradient. You have your quadratic graph, which can also be sloping upside down. You can have the n shape instead, if you have a minus x squared. You have your cubic graphs, which again could be a minus x cubed and would be sloping the opposite direction. And you have your reciprocal graphs, and you have the positive and negative version. So there we go. There are some different graphs, and in this one we had a cubic and a reciprocal. Okay, so in this question we are looking at a quadratic sequence. Now when we have a quadratic sequence, there are different methods that you can use. I know some people learn a formula for this, but I use the logical approach. So over to here, we're going to have a look at what the difference is between these terms. Now in the first instance it's 2, then it's 4, then it's 6, and then it's 8. Which means that there is a second difference to this sequence. The first is 2, and then 2, and then 2. Now, a second difference of 2 is a unique property to the square numbers. If you actually draw out the square numbers, you'll see 1, 4, 9, 16, they have a second difference of 2. We first get 3, then 5, then 7, and then the second difference is 2. So all that finding a second difference of 2 tells us is that it's somehow related to the square numbers. Now, that sequence up there is called n squared, and n squared has a second difference of 2. So whatever you get as your second difference, to find what goes in front of n squared, because it can be 2 or 3n squared, you have to divide the second difference by 2, and that tells us that it's 1n squared. Now 1n squared is the sequence that we've just written out. 1, 4, 9, 16. I'm going to put another one because we have 5 numbers in our sequence. And all we want to do is see, okay, well we know it's related to n squared, but how is it different? How does it differ from the sequence we've been given in the question? Now I tend to write that down as the difference. You can write it down as whatever you like, but to get from 1 to 1, that's a difference of 0. To get from 4 to 3, that's a difference of minus 1. And it's got to be careful when I say difference here, because normally a difference is always a positive value, but here we're just looking how we get from the sequence back to our original. So from 9 to 7, we take away 2, from 16 to 13, we take away 3, and from 25 to 21, we take away 4. Now ideally, we want this difference to be a fixed number. If they were all minus 1 or all minus 2, we could finish this nth term off and just say n squared minus 1 or n squared minus 2. Unfortunately, we have got the hardest version here, and that's where we now need to find the nth term of this sequence here. Now, one thing we can do is we know the nth term is starting with n squared, so we can sort of put that in terms of our final answer. But now we need to find the nth term of this sequence. So at this point, it's almost like forgetting about the entire question. Just imagine we had a question that just said, here's a sequence, find the nth term of that sequence. Well, in that scenario, we would again find the difference. In this case, it's -1, which means it's -1n. And then we find the difference from the -1 times table to this sequence here, and that is adding 2. You can go backwards from the 0 as well, if you would prefer. But here, if we do go backwards, or if we think about this, from -1 to 0 is adding 1, from -2 to 1 is adding 1. So this is +1 on the end of our -1 times table. So the sequence that we have there is just 1 bigger than the -1 times table. That's all that that part means. So this particular sequence is -1n plus 1, which of course you can just write as -n plus 1, or you can leave the 1 in, it's up to you. So it's -n plus 1, which is being sort of added on or subtracted from this sequence, whichever way you look at it. So there we go, n squared
Okay, so looking at
plus
some
1
graphical simultaneous equations where we have
sequence.
the equation of a circle. It says here the diagram shows the graph of x squared plus y squared is 30.25. So for 30.25, which is the radius squared, you can kind of see the square root of 30.25 where the circle is crossing through the axes. So you can kind of see that number there. We can't say it for sure, but that's where the number is going through. It says use the graph to find estimates for the solutions of the simultaneous equations. Then we have our circle equation and we have a linear equation, y minus 2x equals 1. Now we want that in the form y equals mx plus c. So once it's in that form, y equals mx plus c, it's much easier for us to draw. So if we add 2x to the other side, just rearranging it slightly, we get y is equal to 2x plus 1. Now from there we can actually draw this straight line. You can either draw a table and you can do some values and you can sub it in. So x and y, we're going to want to choose a few values here. You only have to necessarily do all of them, but -1, 0, 1, 2 and 3. Just having a look at this region on the x-axis here, we're going to need quite a few more than that, but this is one way that you could approach it. So timesing the x value by 2 and then adding 1, just following this equation down here. Starting with the positive numbers, 3 times 2 is 6, plus 1 is 7, 2 times 2 is 4, plus 1 is 5, and you can now spot the pattern. It's going down in 2s. So it'll be 3, 1, minus 1. You can plot these points on, 0 and 1, just here, 1 and 3, just here, 2 and 5, just there, 3 and 7, just here. And actually it's probably good that I only selected those ones because it would now go off the graph had I have got any further. The other one I had was -1 and -1. Now, I could just get a ruler now and extend the line, but I want it to be as accurate as possible. So what I'm going to look at is seeing if I can spot the pattern between the points. And if you look, it goes across 1 square, up 2 squares. And if I follow that pattern going down 2 across 1 is here, down 2 across 1 here, down 2 across 1 here. I then want to join this up using a ruler and making a nice straight line. Now once I've drawn that, it wants me to use the graph to find estimates for the solutions of the simultaneous equations. So I actually want to find the x and y values at the point where they cross over. That's quite hard to read. So we are only finding estimates. So I want to find these numbers here. So on this particular one, not the easiest to see. It's on 2 though, and about 5.2 by the looks of it. Each square goes up by 2. So, or 0.2. So x is 2 and y is 5.2. And then for the one down here, which is just as difficult to see and it's in the negatives, we have x on minus 2.8 by the looks of it. And y is just above the 5, maybe minus 4.8. Y is equal to minus 4.8. Now obviously when you're doing this, you can get your ruler and you can draw or just hover your ruler above the point just up to the X and Y axes so that you can see it a little bit clearer. But there we go. I've managed to read them. I'm pretty happy with those answers there. Just remember, it does say we're finding an estimate, so we're just doing it as best as we can. The important part there is as well that we've drawn the line on the graph. We've shown that we are where we are reading the values from. But there we go. There is using some graphical simultaneous equations.
Now this question is looking at perpendicular lines. So here it says find an equation of the line that passes through C and is perpendicular to AB. So if we kind of imagine a line which is perpendicular to AB, doesn't necessarily go through the middle of that line of course, but it might be something like this. So it's perpendicular to AB and it forms a right angle. Now drawing it in can help along the way, but ultimately we need to find out what the gradient of that line is. Now we can find the gradient of the line by looking at the coordinates A and B. Now B over here is the coordinate, and let's just have a think. The X coordinate is 0, the Y coordinate is 4. A down here, the X coordinate is -2 and the Y coordinate is 0. So if we want to find the gradient of AB, we can then find the gradient of this perpendicular line. So for the gradient, we will do the change in Y divided by the change in X. So here, the Y coordinates go from 0 to 4. So 0 minus 4, or you can do 4 minus 0, and then over the change in X, which is -2, take away 0. So for that, you can also just think about it as a distance as well. You could do the positive versions. From 0 to 4 is 4, from -2 to 0 is 2. So we can actually just use the positives, which probably would have been nicer in this one. But -4 over -2, which is +2. So the gradient of AB is 2. If we want the perpendicular gradient, we have to do the negative reciprocal. So the negative reciprocal, we change the sign in front of that gradient, so it becomes negative as it was +2. And then we do the reciprocal. The reciprocal of 2 is 1 over 2. So our perpendicular gradient for that perpendicular line is -1/2. So we know what our equation is going to look like. It's going to be y equals -1/2 x plus c. We just need to find what that y-intercept is, that value of c. To do that, we need a coordinate that's on that line. And it's told us that this one passes through the point C. So I just need to substitute that value, or those coordinates, into my line equation. So y is -1. That's equal to -1/2 multiplied by x, which is 5, and then plus c. Now in this circumstance here, we would likely just use the calculator just to make sure we get these values correct, but 1/2 times 5 is just 2.5, and it is -1/2 times 5. So that would just become -2.5. You could leave it as a fraction or a decimal, it's completely up to you. I'm going to write it as -2.5 plus c. To get the value of c now, we just need to add 2.5 to both sides of our equation. That will isolate c. We will then have the value of c. So c is equal to, and again you can do this on the calculator, but -1 plus 2.5 is equal to +1.5. Or you could write that as a fraction. If you want, you could leave it as 3 over 2. So for this one, we now know the value of c. All we're going to do is put this value of c in place of c in the equation that we'd already written. And here we go, we would have y equals -1/2x plus 3 over 2. Now you can write those as decimals if you like. You can write -0.5x plus 1.5, but I tend to just leave the equation that I'm writing either as a fraction or as a decimal, but it's completely up to you.
Now with parallel lines,
how you write it.
for us to show
but there we go, there was
that
dealing
lines
with
are
perpendicular
parallel,
lines.
then we just want to compare that gradient. When lines are parallel, just means that they're going in the same direction and therefore have the same gradient. Now the first line equation that we've called L1 has a gradient of 3. But this second line equation is not in the form y equals mx plus c. So we want to get it in this form. At the moment, it's not, so we need to move the pieces around so it is in that form. I'm going to start by moving the 9x. So I'm going to add 9x to the other side. It's going to be a little bit closer then. We have 3y plus 5 is equal to 9x. I'll also move the 5, so minus 5 to the other side. We get 3y is equal to 9x minus 5. And now I need to divide by 3. And we get y is equal to 3x minus, I'm not going to do 5 divided by 3, I'm just going to leave it as a fraction, 5 divided by 3. The actual number at the end isn't overly important. The important part here was that we have got the same gradient. So I would write some words along with this that just says they both have the same gradient of 3. And there we go, that would show that these lines are parallel. Okay, on to some angles in polygons. Now this particular polygon is an interesting one as it is not a regular hexagon, but it does say it shows a hexagon and it has one line of symmetry. Now straight away you can kind of see that that line of symmetry is going straight down the middle, and there we go, it's the same on either side. It says here angle BCD is 2 lots of angle CDE. So let's find BCD. So BCD is this angle here, and that is 2 lots of CDE. Now wherever we're given a statement like this, that means it's in a ratio. It means it's in the ratio 2 to 1. The one on the left, BCD, is 2 lots of the one on the right. You can pick any variation of that ratio, but 2 to 1 is the one with the smallest numbers in, or the simplest form of that ratio. That can also be written in terms of algebra. So you could say it's 2x to 1x. You can write it like that if you want, just depends whether you prefer to use ratios or prefer to use algebra. Now I prefer to use algebra in this question because it means that I can put 2x in this angle and x in this angle. Now I know all the angles on the other side are all the same as well, so this is 117, this is also 2x, and this is also 1x. There are other variations that you could look at here. You could look at the shape on the right. After we've split it up, we have some right angles here and here. So you could look at the shape on the right there instead and sort of treat that as a different shape and work from that one, and that's fine as well. I'm just going to go for the whole shape here and just see what we get. Now it says it's a hexagon, so regardless of the fact that it is an irregular hexagon, we want to do our working out to find the sum of the interior angles. So our formula is n minus 2 times 180, where n is the number of sides. A hexagon has 6 sides, so 6 take away 2, which is 4, times 180, and we need to work that out. So 4 times 180, well 2 times 180 is 360, so double that is 720 degrees. So we know the sum of the angles is 270 degrees within a hexagon. We just need to find what's left. Now the only angles we know are these 117 degrees at the top. And if we add both of those together, that gives us 234 degrees. So if I start by taking that away from my 720, so 720 take away 234, I'm going to have to do some borrowing for this. So borrow from the 2, 4 from 10 is 6. I'm going to have to borrow again, and then 3 from 11 is 8, 2 from 6 is 4. So there are 486 degrees left in the hexagon. And the 4 angles that we have, we've got written with algebra. We have 2x, 2x, 1x and 1x. As we're looking at all 4 of them, you could write that as a ratio 2, 2, 1, 1. It's completely the same process though, because ultimately we want to add together all of these angles that we have. So we have the 2x plus 2x is 4x, plus 1x is 5x, and plus another is 6x. So we have 6 x's that equal this total 486. Now once we've done that, and we have solved this little equation to find the value of x, we'll be able to find the size of angle AFE, which is in this particular 2x here, by just timesing our answer by 2. So I'm going to start by dividing by 6 to find the value of 1x. To do that, I'm probably going to have to do some bus stop division, so let's do that to the side. 6 into 486. So that goes into 48 8 times, and then it goes into 6 once. So my value of x is 81. For that value of 2x, that means we just need to do 2 times 81, which gives us a value of 162, and that would be our final answer. So the answer for this one is 162 degrees, and that would be the size of the angle AFE, which is obviously, of course, the same as angle BCD. There we go, and there's some angles in polygons. So for this question, we have some right-angled triangles, and we're looking at Pythagoras and trigonometry. Now here it says work out the size of angle KLM, and KLM is this angle here. Now using trigonometry for right-angled triangles, we need at least two sides. So at the moment, we've only got the 15. But we do have a connecting side with another triangle attached to it. So if we can find the length of that side, that would be the opposite side when we get there, and this is our hypotenuse. So we can use SOHCAHTOA to find that angle. We just need that missing side. So before we get started on finding the missing angle, we'll use Pythagoras' theorem on this right triangle here. So we have 7 centimetres and 4.5. They are two of the shorter sides. Pythagoras' theorem is a squared plus b squared is equal to c squared. So all we need to do is square both of those. We are finding the longest side here, so we will add them together. We're going to type that into our calculator. So 7 squared plus 4.5 squared gives us a value of 69.25. We just need to square root that answer. That will give us the length of the side. So square root of the answer. And it doesn't give us a very nice number. Now, of course, we're not going to get a very nice number if we're square rooting 69.25, but we do end up with quite a long decimal. So 8.321658,489. It says to give your answer correct to 3 significant figures. Now at the moment, the answer that I have for that middle line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 significant figures long. Now I could probably do it to 5 significant figures and it's not going to mess up my answer. However, I'm just going to leave that number in my calculator, and then when I come to use it in a second, I'll use my answer button just to put that number into my next working out. So I'm going to label it as 8.32 here. However, I am going to use the full number. So I now have a right angled triangle with O and H. So you need to know your 3 formulas, whether you use the ratios or whether you use formula triangles. I'm going to write it as formula triangles here. O and H is in our sine formula. So we will be using sine when looking for an angle. I cover up the S and it's O divided by H. Now when finding an angle, we do have to press shift sign first, which brings up our sin minus 1, and we're just going to put our fraction in, which is O, which is the 8.32 over 15. Now if you are typing that number back in and not using the answer button, do type the full answer back in. I'm just going to press shift sign, use my fraction button, and then do the answer over 15. And when I press equals, I get 33.69537249. I didn't really need to write the whole number down there because it does only want it to 3 significant figures. So 1, 2, 3, chopping it after the 6, we get 33 point, so 9 after the 6, so 33.7. We are looking at an angle here, so that is degrees. So there we go, our final answer for that one is 33.7 degrees, and that was using Pythagoras and trigonometry. Okay, so looking at some further trigonometry, this is one of those types of questions that just involves everything. It says ABC is a triangle, D is a point on AB, work out the area of triangle BCD. Give your answer to 3 significant figures, but we'll deal with that right at the end. So triangle BCD is this triangle here. And let's just think about what we need in order to get the area of that triangle. Well, we've got an angle of 25. If we were to use that angle, and the formula for the area, we're going to be using the area is equal to half AB sine C. So if that angle is our C, we need the A and the B, meaning that we need this length here, let's call it X, and we would need this length here, let's call it Y. Now at the moment, of course, we have neither of those. So we need to have a look at the other triangle and think about how we could possibly get one of those lengths. Now, if we look at this triangle on the left, we have got enough information to find this side opposite the angle. We can use the cosine rule for that. So the cosine rule for a side length is a squared is equal to b squared plus c squared minus 2bc cos a. Now you can rearrange the letters in that formula, but I tend to just use one version of the formula, and I'll call the angle that I'm going to use my large A. Now as it so happens, it's got an A next to it anyway, but that is going to be my big A, and then the x that we're looking for there is going to be my little a. The other two sides are going to be B and C, so there we go, we can just plug these numbers in, and we'll find one of those first two lengths that we need. So if we put those into our formula, and it's completely up to you here, what I like to do is I like to figure out A by doing the square root of everything, and then putting everything in my formula all in one go. Completely up to you, but if you are answering these type of questions, I'd imagine you're quite happy to do that step there. So we would have 4.9 squared, and a kind of, you know, especially if you're sort of following along with me, sort of typing it in as you go, just to make sure that you're happy to type it into your calculator. Although it's not the hardest to type in, particularly after some of the other types of calculator use we've done. The next one would be 3.8 squared. So again, 3.8 squared, and then take away 2 times 4.9 times 3.8 cos 80, and it will open up a bracket, and that angle there goes in your bracket. So typing that into the calculator, we are going to get, I would imagine, quite a large number, and that's absolutely fine. It does say 3 significant figures, but we will write this out in full to start with. So 5.655381673. And there we go, that is that length x. Now for the moment, I'm just going to write 5 point, and let's just write 655. That's going just beyond the 3 significant figures there, writing 4. Just so it's labelled on the diagram. So now we need to figure out how on earth we're going to find side y, because we still don't have enough information on that triangle on the right. Now we can use either the sine rule or the cosine rule, of course, to find missing side lengths. However, if we look at the easiest route to get there, we now have one other side length. Now ideally, we would like either the angle opposite that, so that we could then use the sine rule. We could pair this up, and if we know that angle, we'll know this angle here, and then we can do pairs of opposites. So it doesn't really matter which angle we find, but we'll be able to use the sine rule if we can get one of those angles. So that's kind of our next problem now. How do we get one of those angles? Well, looking at the triangle on the left again, is there a way we could get maybe this angle here, next to the other one within the triangle, next to that letter D, or maybe that top angle? Now we can definitely get that angle there, or the top angle, because we can use the sine rule on this triangle. On this triangle here, we also have pairs of opposites. So if we get rid of some of this working out, we'll swap to a different colour. We have this pair of opposites. The 80 is opposite the 5.655 we've just worked out, and the 4.9 is opposite this angle here. So if we use the sine rule to figure out that angle, we can do angles on a straight line to figure out on the other side, and then we'll be able to use the sine rule in our finishing triangle to find the length of y. And then of course we've still got to get the area of that triangle. So we have a lot to do. This is a huge question. So let's use the sine rule on this triangle on the left. So the sine rule is A over sine A is equal to B over sine B. And you can write equal to C over sine C as well. We only ever use 2, so I just tend to label them A and B. Now, as it just so happens, we have actually labelled the A and B already from the previous working, and that works nicely for this one. So we can actually just stick with that labelling. If the letters were different, we would want to swap them around and sort of relabel it. But as it so happens, this works out quite nicely. So A is our 5.655 number. 5.655 over, and opposite that, our big A is 80, so over sine 80, and that's equal to, B is 4.9, so 4.9 over, and then we don't know the angle. So in this scenario here, where we are looking for an angle, we actually would normally flip the sine rule over, so make sure we have it set up for finding an angle. But we can just flip them over at this point. It doesn't matter, you can either put it all in the first place, or you can flip it over at a later stage. So I'm going to flip it over now. So we have sine 80 over 5.655 is equal to sine x over, And let's just go with the 4.9. There we go. I've labelled that x. I should probably get rid of the x now because I don't want us to get confused with the side length. Now we're trying to find this angle, so we'll call that x. Now we can rearrange this. To get sine x on its own, we need to multiply both sides by 4.9. And if we multiply both sides by 4.9, we'll have something we can type in our calculator and we will get that angle. So we have 4.9 sine 80. And that is over 5.655. That's equal to sine x. Now we don't want to know what sine x is, and hopefully you are sort of confident with trigonometry in the sense that we need to do the inverse of sine. You can type it all in one go, or you can type in 4.9 sine 80 over 5.655 and then do the inverse sine of your answer. That's how I'm going to do it. So I'm going to type in 4.9 sine of 80. And on the bottom, 5.655. And when I type this in, I'm going to type in a few more of the decimals as well, just to make sure it's as accurate as it can be. I've got it written down over on the bottom right. So 7.3 at the end. We'll type that in. And we do get a decimal. It's 0.85 and a few more decimals there. So I want to do the inverse of my answer. I could write it in there if you want. I'm confident I've got the correct answer written in there though. I'm going to do sine minus 1 of my answer. And I do get 58.5689, a few more. I'm not going to round it, I'm just going to keep it as 58.5689. I'm just going to leave it there. It is a 4 afterwards, so technically I am rounding it. But that's going to be enough decimal places there, or significant figures as well. We've got it to 6 significant figures. It wants our answer to 3. I don't want to just sort of overcrowd everything with tons of numbers. There was actually only 2 numbers left, but that is enough for this angle. So I'm going to label that up here. That's 58.5689. You can already start to see, even with a whole page, you would start to get, this is going to start to get a little bit messy. So let's now move into this triangle. We've used the sine rule. We can move on to the angle next to it. So 180, take away my answer. And next to that now, this is 121.43. I'm going to round it to 2 decimal places now, or 5 significant figures, because it is starting to get to a point where there's just numbers everywhere. Now I can do the sine rule again. So if you're already happy with the sine rule, we're now doing the sine rule for lengths. I want to find this length here, which is opposite this 121. I can find the angle in the bottom right because its angle's in a triangle. So I'm going to do 121.43 plus 25 and then take that away from 180. So that leaves me over here with 33 point, and then it's 5689. Again, I've used the full number every time, so I get 568949. So at this stage, I'm just going to write the full number in so I don't get any rounding errors. And there we go, that angle there is opposite this 5.655. So I'm going to use the sine rule again. I'm going to do that over on the left, so it's quite a distance away from the shape now. I'm going to keep that top right space there for the final step. So using the sine rule, and again we need to label this up. So this time I'm going to call my y A and my angle big A, and then this 5.655 will become my B, and this will become my big B. And again, just using A over sine A. So we have y over sine of 121.43, and that is equal to the 5.655 over sine of 33.568, or it just round up for my bracket here, so 569. I need to rearrange this, so y is equal to, and then I'm going to have the sine 121 up on the top, so 5.655 sine 121.43 all over sine of 33.569. I can just type that all in one go. That is going to give me my answer. There's a lot to type in. So 5.655 sine 121.43, and on the bottom
we have sine of 33.569. If I press equals now, I have got an answer for that side length, which I have called y. Y is equal to 8.72658753. And again, I have used some rounded figures there, so this might be ever so slightly different if you've been using different rounding to me. Right, so that is the length up here. We now have 8.7265 and a few more decimals. Okay, so I now have all of the information that I need to work out the area of that triangle. If I was to redraw it, which might be helpful at this stage, it might actually not, because we're just sort of creating more writings and more drawings everywhere. We have the angle of 25. We have the side length over here, which is 5.655. And we have the side length on the other side now, which is 8.726 or 8.72, and that 6 would round up. Let's just keep it as 6.5. So I can now use half AB sine C. I can use my area of a triangle formula. This is going to finish the question, thankfully. There's a lot of working out up to this point. So I just need to type into my calculator 1/2 times A. It doesn't matter what order we put A and B in. So we've got 5.655 times 8.7265 times sine of 25, the angle that we're using there. So I need to type all of this in. 0.5 times 5.655 times 8.7265 times sine of 25. And there we go. Now all of that has led to a final answer for me, which has come out as 10.42775 and a few more decimals. I'm not going to worry too much though, because I do need to round this to 3 significant figures. So if I cut it after the 4, I get a final answer, which has come out as 10.4. So all of that, and I've got to a final answer. I'm going to write it down here, 10.4. This was an area, so it is centimetres squared. And there we go. That's the final answer after all of that working. Now you can see there was an awful lot. So it's not necessarily always going to be the case that you're going to have every single part of trigonometry within one question. The only thing we didn't really do there was using the cosine rule for an angle. But there we go, pretty much all of trigonometry.
Okay, so looking at some angles in parallel lines.
There is some further trigonometry.
It says here ADC is a triangle. It then tells us that AED and ABC are straight lines, and it tells us that EB is parallel to DC, which we can see by the arrows on the diagram. Now it says here to work out the size of angle EAB. EAB is this angle here at the top of the triangle. And it says you must give a reason for each stage of your working. And those reasons there are going to make up the large majority of the marks on questions like this. So for starters, before we try and find that angle, all I'm going to do is I'm going to look at this diagram, thinking about angles on straight lines, which have been mentioned, and angles in parallel lines, which have been mentioned as well, and of course angles within a triangle. Now if you look at this diagram, there is a small triangle sitting on the top, none of the angles we have within that triangle. There is also a large triangle all the way around the outside. And we do have one of the angles in that triangle in the bottom left. We know that with angles in a triangle, we need at least 2, unless of course it's something like an isosceles triangle where we can match up and find the base. However, it doesn't tell us anything to do with that. So in this question, I'm just going to have a look and see if there's anything that I can find. Well, we have these angles here on a straight line, and there's 2 angles next to one another. So straight away I can find this angle here next to the 148. Now when I label that, I am just going to label it next to the diagram. I'm going to write my working out next to it. So 180, take away 148, leaves us with 32 degrees. So I know this angle here is 32, and of course I need to give a reason, so I would write angles on a straight line equal 180 degrees. Now once we've done that and we have found one of the angles, we need to have a look and see if we can find any other angle at all. So looking at the angles on straight lines, there's nothing left to be found. There's still nothing within the triangles, so we have to think about the parallel lines. There are two types of angles primarily that we're going to have a look at. Now here, because there is no additional lines sort of shooting out of the shape, we can't really find any of those alternate angles that make that nice Z shape. So we're really going to be focusing on looking at corresponding angles, which are on the same side of those parallel lines, which make this sort of shape. And we're also going to be focusing on co-interior angles, which are on the insides, but on the same side of parallel lines. So we have those two that we're going to focus on. So thinking about co-interior angles, we could use that just here to find this angle. That'd be one option, and there's a lot of options we can take here. So that's one option we could do. We could also have a look on the other side, and we could use co-interior angles to find this angle. That's another option. The final option, and it doesn't matter which one of these we take, we could use corresponding angles. We could find this angle just here, which is the same as the 63. Now it doesn't really matter which one we go for, any of them would be fine. As this is the last one that I happen to draw, and this is purely by chance, not because this is my favourite, it's just this would be 63. Now next to that, I would want to label it as well. You can write this, in nice written proof down the bottom. You can say angle AEB equals 63 and write your reason next to it, or you can just label it near the diagram. So I'm going to say here that A, and I'll write it as you could down below, we'll say AEB equals 63 degrees because corresponding angles are equal. And there we go, there's another reason and another angle that we found. Now we just need to have a look and think, based on that angle that I've actually found, can I now find that top angle in the triangle? And the answer is yes now, because we have this triangle here, we've got the two angles down the bottom, and we know angles in a triangle add up to 180, so we can find that final angle. Now this is the only problem with labelling the diagram, is that sometimes you are going to just run out of space to actually label that. So it is good to be able to write the proof down below as well. So I'm going to say EAB is equal to 180, subtract the total of, we'll say 63 plus 32. We need to work that out, so that is 180, take away 63 plus 32 is 95, and that is equal to 85 degrees. Next to that, I need to finish off by putting my final reason, which is that angles in a triangle add up to 180 degrees. I'm just going to put angles in a triangle equal 180 degrees. Okay, just for simplicity of our example here. So there we go, that angle is 85. And of course, there were other ways that you could do that. If you did go and find the bottom right angle using co-interior angles down where that letter C is, you'd find that that one's 32, does match the co-interior angle that we'd already found anyway. And then you could have looked at the big triangle around the outside, or you could have found the angle just underneath the 63 that we've just drawn in as the co-interior angle, and then found 63 using angles on a straight line. So lots of different ways that you could have approached this, but there we go, there's one method along with all of our reasons at each stage of our working. Okay, and looking at some 3D trigonometry. Now we've looked at quite a lot of the further trigonometry, which can be involved within 3D trigonometry as well, but this one here is a relatively nice one within a cuboid. It gives us some lengths and an angle in the question, so we want to label that on before we start going ahead with everything. We have 7.3 as this back length here, which is the same as the front. It might actually be easier if we write that on the front, so it's just out of the way a little bit, so 7.3. C to H, which is going up the side, is 8.1. And angle B to C to A is 48. Now if I go from B to C to A, which isn't the nicest one to draw, there we go, it creates this angle here. So that is my 48. It says find the size of the angle between AH and the plane ABCD. Now the plane is the flat surface on the base. So between AH, A to H goes up to here, and the plane, and we've already drawn that line in, and that's this angle here. sort of in the space inside the shape. So that's what we're trying to find, this angle. We'll call it x for now. Now if we look, that creates a right angled triangle within the shape. And if I was kind of to draw that to the side, we have a right angled triangle. We have the length of the height, well the height of it, the length of this height here, 8.1. We don't have the base, but we have the 8.1 and we're looking for that angle. So if we can find the length of the base, well we can use SOHCAHTOA and we can work out the angle. So there must be a way of working out that length. Now if we look at the sort of base of the shape, this rectangle, and we were to draw that out, we don't know exactly the scale of it because we don't know all of the lengths here, but let's go with the 7.3 just here, and we'll split it up, and this here is 48 degrees. This is also 7.3 on the top. Could we work out this missing length in the middle? Of course, that is the base of this triangle. And the answer is yes. We have a right angled triangle there. So we can use SOHCAHTOA. We have the opposite side, and this is the hypotenuse, as that's the right angle in the corner. So that is my SOH formula. So we're going to use sine to work out that length, and we are working out the hypotenuse. So we would cover up the h or rearrange your formula, whichever way you're doing this. So O divided by S would be 7.3 divided by sine 48. And then we go, we can type that into the calculator. That is 7.3 over sine 48, and that comes out as 9.82. So that 9.82 that we've just worked out, we could put a few more decimals with it if you would like. We want it to one decimal place, so let's do a few decimal places. That length there, being the diagonal from A to C, is also now the base of the triangle that we're looking at in the middle. So that here is 9.8231. And now I can do SOHCAHTOA all over again. So opposite this angle is the opposite. We don't have the hypotenuse, but we do have the adjacent. So this time we will use our tan formula. Whether you use it as a formula or whether you use a formula triangle, absolutely fine. When we're looking for the angle, we need to do the inverse of tan. So we're going to do tan minus 1, and then it's the O over the A. So 8.1 over 9.8231, and then we need to just type that into our calculator. So tan minus 1 of 8.1 over, and just make sure you do type this in correctly. It's a lot of working out to do if you then type an incorrect number in, 231, and that equals 39.508. A few more decimals, but I'm going to stop there because it did only want my answer to one decimal place, so we can cut it after the 5. It's a 0 afterwards, so that comes out as 39.5. Remembering this was an angle, so 39.5 degrees, and that is using SOHCAHTOA in some 3D trigonometry. Of course, not forgetting, you can have to do further trigonometry within SOHCAHTOA, but there we go. There was a nice, or a relatively nice question that only involved right angled triangles. Okay, so looking at some bearings and trigonometry. This is our last question looking at trigonometry now. So here we've got lots of information, but it says it wants us to find the bearing of Chorlton from Acton. So if we join those two together, Chorlton and Acton, the bearing is all the way around this distance here. So we need to find this angle. If we find that angle, we can add that to the 37, we'll get our final answer. Now at the moment, we don't have a huge amount of information in order to get that. We'll probably be able to use the sine rule at some point, but we need to think about these parallel lines that we have with our north lines. Now the first one that stands out is that we have a co-interior angle just here. So to work out this angle at the top, we could do 180, take away 37, which tells us that is 143. We now have angles around a point, and we can figure out this angle here, which is 67. Now using that information, and let's get rid of this arrow just here and our highlighting now, we can actually find the length of the line that we've drawn in. So to get this line here, we can use the cosine rule. So we'll call this our little a, and this our big A.
And the other two sides on that triangle there are our B and C. So for A, it's the square root of, and you can write A squared equals, and then do the square root if you prefer, but it's B squared plus C squared minus 2BC cos A. So the value of A will be the square root of, and we have 8 squared plus 9 squared minus 2 times 8 times 9 cos, and then we have 67. So if we type that into our calculator, the square root of 8 squared plus 9 squared minus 2 times 8 times 9 cos of 67, we get A is equal to 9.4199. And that's our length down here, so 9.4199. Now we can actually use the sign rule. As we have a pair of opposites just there that we now have labelled, and this is another pair of opposites here. When using the sign rule for an angle, we do want to use our flipped version of the sign rule. So we're going to use, and we'll do this in the bottom left, sine A over little a is equal to sine B over little b. So let's call our angle here B and the opposite side little b. So we have sine of 67 over 9.4199 is equal to sine x, the angle that we're looking for, over 9. We can rearrange this now by multiplying the 9 to the other side. So we get 9 sine 67 over 9.4199 is equal to sine x. Now we can type that into our calculator, and then we'll do the inverse of the answer. Or you can type it all in one go, completely up to you. I'm going to press sign -1, and I'm going to put the fraction into my calculator straight from there. So 9 sine 67 on the top, 9.4199 on the bottom. And there we go, our final angle there is 61.578, and a few more decimals. Now this question wants our answer to 1 decimal place, so we're going to need to round it anyway, but I need to add this angle, the 61.578, onto my 37. Now I may as well round this number, and that's 61.6, as it wants it to 1 decimal place. So if we add that to the 37, let's have a look. So 37 plus the 61.6, that gives us a total of 98.6 degrees. Now we want to write that as a bearing as well. So the third digit needs to be before the decimal place. So we have 098, there's our 3 digits, and then we have a 0.6 as well. So there's our final answer, 0.9 or 098.6 degrees, and that is our bearing of Chorlton from Acton. Okay, so looking at a frequency polygon. Now a frequency polygon, we need to plot on the midpoints of our groups. So between 0 and 10 is 5, 10 to 20 is 15, 20 to 30 is 25, and then we have 35 in our last one. We just need to plot these at the correct heights for the frequency. So from 5, we need to go up to 14, which is just here. From 15, we need to go up to 18. From 25, we need to go up to 26. And then from 35, we need to go up to 12. So up to 12, and there we go. Now a frequency polygon is just joined dot to dot with straight lines. So we're going to join each point. We would use a ruler for this, and just making nice straight lines between those 2 points. And there we go, that's your frequency polygon. For a scatter graph, regardless of what the question is asking, we need to draw a nice line of best fit. So if I draw a line of best fit for this one, where there's around about the same amount of points above and below, then we can start answering the question. It says here 1 point is an outlier. Now an outlier is one that's normally the furthest away from the line of best fit, and it doesn't tend to follow the usual trend. So over here there is a point which is an outlier. It says write down the coordinates of that. If you look down from that point, you can see that there is 100 on the x-axis, and on the y-axis it's sitting right next to 18. So 118 are our coordinates. For another day, 370 cars pass this point, and this is about the carbon monoxide levels for a certain amount of cars. It says estimate the carbon monoxide level for this day. So we need to find 370, which is 3 squares before 400. Make sure that you check the scale. This is 370. And then we're going to go up to the graph from 370, and then we're going to go across from that point and drawing that with nice straight lines. Now mine comes out as 14. Yours might be slightly above or below that, but mine came out as 14, and that's in milligrams per metre cubed, which I've just spotted on the axes there. The final part here says, Alfie says, because there's an outlier, there's no correlation. Is Alfie correct? You must give a reason for your answer. Now we can already see that there is in fact a positive correlation, and actually the outlier is just something that we would disregard. You might have used in other subjects the word anomaly. It doesn't mean that there's no correlation, it just means that there was one particular day where there was an anomaly. So any of that explanation there stating that it does in fact have a positive correlation and that we would just disregard the outlier would be a perfectly fine answer. But there we go, that's how we would use a scatter graph. Now with grouped frequency, we could be asked multiple different things to work out. This particular one is asking us for the modal class interval. Now modal is just another word for the mode, which is the most common. So we want to have a look at the number of adults in this question, and it's about their foot length, and see where the most are. Now the most are in this category here, so we would just write down the category 22 to 24. And there we go, that's our modal class interval. It then says as well to calculate the mean. Now when we are working out the mean, we always just multiply across the rows, get the totals, and then divide by how many there are. And in this case, there are 40 adults. But with group frequency, we have to use the midpoints, and that's why we are only finding an estimate. We don't actually know the size of people's feet in these particular categories, but we use an estimate to get an estimated total. So we'll write down all of the midpoints. Remembering you can add the start and the end of the category and divide your answer by 2, and that will also give you that midpoint. So just typing these in on a calculator, 17 times 3 is 51, 19 times 6 is 114, 21 times 10 is 210, 12 times 23 is 276, and 9 times 25 is 225. Now we just need to add all of those together, so add them all up really carefully on your calculator. You don't want to miss a number or type it in too quickly. We get a total of 876. Now we were told that there was 40 adults. If not, we could find them there anyway. So we just need to divide our answer by 40, and that's going to give us our estimated mean, and that comes out as 21.9. Now always check your answer, make sure it makes sense. 21.9 falls into our range of data here that goes from 16 to 26, and 21.9 would fall into this category here, which is close to the middle. In fact, that category is actually in the middle. So there we go, 21.9 is our mean. Now with sampling and bias, it's a relatively nice topic. We're just looking at proportion. It says here that Sam takes a sample of 50 people. It says that there are 700 people in a fitness club. How many sports bags should Sam order? Well, here he had 17 people that wanted the sports bag, and that was 17 out of 50. So if we're looking at 700 people, we just need to work out that fraction of 700. So you could divide by 50 and times by 17, just doing a fraction of an amount. Of course, you could always look at this as a fraction out of 700 as well and make an equivalent fraction. Now 700 divided by 50 on the calculator tells us that we need to multiply by 14 to make that equivalent fraction. So if we do the same to the top as well, 14 times 17 is 238. So there we go, our answer would be 238. Now this question says to write down any assumptions you made and explain how this could affect your answer. So in this type of question, we are assuming that the sample represents the rest of the people. If the sample does not represent the rest of the people, then our answer could be bigger or smaller. And notice how I emphasised the fact that I mentioned my answer. So this is specifically asking you, how does it affect your answer? So we assume the sample represents the rest of the people. If not, our answer would be bigger or smaller. And there we go, that's sampling and bias. Okay, so looking at a stem and leaf diagram with a box plot. Now for a box plot, it's quite nice to plot the lowest and the highest value. And we can see that in the stem and leaf. We have this number here, and also this one just here. Look at the key to make sure that you know what those numbers represent. The smallest number there representing 173. So that's just here. Check the scale on your box plot just to make sure that each square is 1. If not, obviously just be careful when you're plotting that. 219 is just before the 220, and there we go, that's our smallest and largest value. Now to find the median and quartiles, particularly when we have all of those three to find, I would take a statistical approach for 23 flowers here, rather than crossing all the numbers off and having to then find the quartiles inside all the crossed off numbers. So here, 23, add 1, divide it by 2, that tells you where the middle is. So that's 24 divided by 2, that's the 12th number. So I just need to count along, and I'll underline them so you can see my counting. 6, 7, 8, 9, 10, 11, 12, and there is the middle, 197. So going down from 197, that draws our median. You might want to label these. I'm just going to label it as the median, 197. I then want to find the lower quartile and the upper quartile. I'm going to label them both here just so I don't forget them as I'm doing them, just in case I need to check them. And then to find the quartiles, we do the same as what we did for the median, add 1, but for a quarter, we divide by 4. And we get the answer 6. So we're looking at the 6th number. So that's 1, 2, 3, 4, 5, 6 from the start. There's our lower quartile, and that is 188. And then 1, 2, 3, 4, 5, 6 from the end. And there's our upper quartile, and that's 209. So plotting those on, we have 188, which is 2 before 190. And we have the 209, which is 1 before 210. And then there we go. We can join this together, and that's what our box plot looks like. And there we go, there is drawing a box plot and using a stem and leaf to find different averages. Now for our next question, we are looking at some percentage profit. It says here, Emily buys a pack of 12 bottles of water. The pack costs £5.64. She sells all 12 bottles for 50p. Work out Emily's percentage profit and give your answer to one decimal place. So to start with, the original cost was £5.64. When we're looking at percentage profit, we just want to do the profit or the change, because they might have made a loss as well, over the original cost, and then multiply that by 100 to turn it into a percentage. So here we actually need to work out the profit. So the original we already have, £5.64. So to work out the profit, we need to work out what she actually sold them for. So here we have 12 times 0.5 or 50p. We can do it in pence and then convert it. I've just converted it first, and that comes out as £6. So £6 is what she sold them for. She paid £5.64. So if we work this out, it will tell us our profit. So 6 take away £5.64, and that is equal to 0.36. So the profit she made is 36 pence. It's up to you whether you keep it in pence or convert it all into pounds, but I've got it in pounds. So I've got the profit, 0.36, over the original, £5.64, and I just want to multiply that by 100, just so that turns it into a percentage for me. 0.36 times £5 over £5.64. I'm just going to press times 100 straight away, just make sure it's not within the fraction there. And there we go, it comes out as 6.38297. There's a lot of decimals here, so I'm going to stop there because it does only want my answer to one decimal place. So I'll chop it after the 3, and that is 6.4%. And there we go.
Okay, so this question
Emily's
here, one that always tends
profit.
to throw people. It's about ratios to fractions. It says that there are 4 types of cards in a game. Each card has a black or white circle or a black or white triangle. So there are 4 types of cards. The number of cards with a black shape to the number of cards with a white shape is 3 to 5. The number of cards with a circle to the number of cards with a triangle is 2 to 7. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Okay, so this question is a relatively interesting one. So here it says, in this final line, express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Now looking at our ratios, we can look at the total number of cards with a black shape as a fraction, because it tells us that here, black to white is 3 to 5. So the fraction of cards that are black shapes, and we can label this down here, so the black shapes The 3 represents the black shape, so it's 3 out of, in total, 8. So that's the fraction of cards that have a black shape on. We can then do exactly the same with the circles and triangles. And it wants to know out of the total number of cards with a triangle. Well, this ratio here adds up to 9, and the 7 represents the triangles. So let's just draw a triangle. We'll have triangle, therefore, is 7 out of 9. Now, it's a little bit strange because we are dealing with fractions, and it wants us to express the total as a fraction. So the total number of cards with a black shape is 3 out of 8. And if we express that as a fraction out of the total number of cards with the triangle, which is 7 out of 9, we kind of break a rule here. We have fractions within fractions. Now, if we ever have a scenario like this, that fraction line means a divide. So actually what we have is 3 over 8 divided by 7 over 9, and actually it doesn't need to be written as a fraction. So that one there, we are now actually just dividing fractions. We know when dividing fractions, we are going to multiply by the reciprocal, and the reciprocal is 9 over 7. So that's nice and easy for us to do. We now just need to multiply the tops. 3 times 9 is 27, and the bottom, 8 times 7 is 56. So actually that whole question there was just about dividing fractions. But we had to first convert the part of the ratio that we needed into a fraction, and the second ratio, the part that we needed, converting it into a fraction. Just following the instructions, it said then express the total as a fraction of the total. So we got the fractional amount for the black cards on the top out of the fractional amount for the triangles on the bottom, and that was then converted into a divide calculation rather than writing just as a fraction. So there we go, 27 over 56, and that is ratios as fractions.
Now, when looking at depreciation, this is the word for when something goes down in value. So here it says Jack bought a new boat for £12,500. The value, which is V, of Jack's boat at the end of n years is given by this formula. So the value of the boat is equal to £12,500, the starting price, multiplied by 0.85 to the power of how many years. At the end of how many years was the value of Jack's boat? First, less than 50% of the value of the boat when it was new. So we're looking at when is that boat going to hit that 50% of its value, or below, because we're looking at how many years. Now 0.85 as a start is the decimal multiplier for 85%. Now if we are multiplying by 85%, that means the boat is going down by 15%. We can figure that out, of course, by doing 100%, the original value, take away 85, and that tells us it's going down by 15%. So in a question, if it said the value is going down by 15% or it depreciates by 15%, this is the multiplier that we would use, 0.85. And you can just type into your calculator 85%, which comes out as 0.85, using that percentage button. And I will link a video in the description for you to have a look at how to use that percentage button for other topics. So there we go. We just need to type this into our calculator. So essentially, because we don't actually have to figure out that decimal, this is really just using a calculator. So if I type in 0.85, I need to pick an amount of years. Now, first of all, I might just want to think to myself, well, what number am I actually trying to achieve here? So if we divide it by 2, the value of the boat, because we were looking for when it hits that 50%, we'll divide by 2, and that is £6,250. So let's pick an amount of years, 12,500 multiplied by 0.85, and let's just go for a power of 5, and that would be 5 years. So for 5 years, the value of the boat is £5,546.31 if we round it to the nearest penny. Now that's gone way below the 6,250. So I'm going to go back into my calculator, I'm going to delete the 5, I'm going to put a power of 4. Now for 4 years, the value of the boat is £6,525.31. and 7 pence if we don't round that. Now that is not 50% of the value, it's not quite gone under. So actually it's going to happen in that 5th year. So at the end of how many years was the value of Jack's boat first less than 50%? Well, after 4 years it wasn't less than 50%, but in the 5th year it was. So my answer for this is 5 years. You actually notice there that just completely by chance I actually got it on the first pick. And that can happen sometimes, and that's always a great little sort of moment when you do get it in that first pick and you don't have to test again. But this particular question, you did have to test at least 2 values there, even if you got the 5 years in the first pick. Of course, if you'd have gone for 2 years, you'd have then had to go for 3, and then 4, and then you'd eventually get it on the 5. But it's not going to take you too long, just to use that left and right button in your calculator to change the power. But there we go, that is some depreciation. Okay, so looking at some compound interest. This question here says Charlie invests X pounds in better investments for 3 years, and Sadia invests X pounds in Country Bank for 3 years. Now, as they both have an X with them, that means they've both invested the same amount of money. It says at the end of 3 years, the value of Charlie's investment is £344,605. Work out the value of Sadia's investment at the end of 3 years. So we need to know how much they invested, and that's what we're going to use Charlie's final amount to figure out. Once we've got that, we'll work out what Sadia gets. Now this is some reverse compound interest, so we need to reverse this process. So we need to know exactly what calculation we would have typed in for Charlie in better investments if we knew his starting amount. Well, we'll call his starting amount X, so we would take his starting amount, X, and we would have multiplied that by 1 point, and then whatever this is as a decimal, so 2.5% is 0.025, so 1.025, and he's invested that for 3 years. And as a result, we got the answer 344,605. So to figure out what that starting amount was, we just need to divide both sides by 1.025 cubed, and we'll divide this answer here by 1.025 cubed. There we go, that's going to tell us his starting amount. So let's type that in, 344,605 divided by 1.025 cubed, and that comes out as a starting amount, 320,000. There we go, and that is the value of X. So the starting amount is 320,000. So that's what Sadia has at the start. We've now worked this out, £320,000. So now Sadia invests into Country Bank. She gets 2% for the first 2 years and then 3.5% for each extra year. So we're going to first work out how much she gets for that 2%. So 320,000 multiplied by 1 point. 2% is 0.02, so 1.02. And we're going to do to the power of 2 there because it's for 2 years. And then we'll deal with the 3.5%, which is 0.035. So we'll start by working that out. 320,000 times 1.02 to the power of 2. And that gives us a total of £332,928. So that's what Sadia has after 2 years. So we're going to do 332,928 times 1.035 this time for the 3.5%. We don't need to put a power with that because this is the 3rd year. So I can just press times 1.035 and I get my final answer, which is £344,580 and 48 pence. And there we go, that's our final answer. At the end of 3 years, Sadia would have £344,580 and 48 pence. And there we go, that's our final answer. Now, there's another compound interest question here. As this reverse compound interest is one just to be careful of, but this question here does have 5 years, and we're trying to work out the percentage. So it says here Natasha invests £6,000 for 5 years. The investment gets compound interest of X% per annum, and at the end of 5 years, the investment is worth £8,029.35. So this time we're working out the percentage. So it's different to the previous, even though they are both reverse compound interest questions. Now, if we knew the percentage, we would do 6,000 multiplied by, and it's a bit of a strange one because we don't know the number there, but it would be 1 point, usually 0 something, okay, because it's normally a single digit. So we don't know what it is, and that's what we're going to need to figure out. So for the moment, let's just call that multiplier the letter x, as that's what it's told us is a percentage. It's going to be to the power of 5, because there's 5 years, and we're going to get the answer £8,029.35. So this isn't too bad to do, because at this point we just need to divide both sides by 6,000 so that we'll know what x to the power of 5 is. It's more the multiplier at the end we're going to be really careful of. So that would leave us with x to the power of 5 is equal to, and we have £8,029.35 divided by 6,000, and that comes out as 1.338225, but this is x to the power of 5. So we need to do the fifth root of this number. So just like when you reverse a square root or a cube root, here we just need to do a fifth root. And there is a button on most calculators which is a square root button with like a little square next to it. So mine is behind a button that has an X with a little square on it. So I have to press Shift to get that button, and then I can put a 5 in the root box and then type in 1.338225, press equals, and I get x is equal to 1.05, and then lots of 9s. There's 4 9s there, 1, 2, 3, 4, 5 9s, 0, 8. Now, because this amount of money in the question was likely rounded to the nearest penny, it has changed this ever so slightly. So you can see the most likely thing is that this is 1.06. All those 9s there, it's so close to 6, and that's just probably because the amount of money has been rounded to the nearest penny. So here, the multiplier that would have been used would have been 1.06. So up here, where we were thinking about, well, what would this number have been? Well, if the number there is a 6, that would relate to 6%. And there we go. And that's the exact answer that we would get. So the value of x, the actual percentage, is 6%. That's what would go in the multiplier there if we were using 6%. And there we go. That is some reverse compound interest. Okay, so in this question, we're going to be having a look at exchange rates, but also some unit conversions as well. So it says here, in London, 1 litre of petrol costs 108.9 pence. In New York, 1 US gallon of petrol costs $2.83. It then gives us the conversion from gallons to litres and the conversion from pounds to dollars. It says in which city is the petrol better value for money. Now, in this type of situation, we need both of these to be in the same units and in the same currency. So I'm going to start by converting the currency and having a look at in London. So here it's given to us in pence, but we want that in pounds. So that's £1 and 8p, but also has the 9 after it there. So we have £1 and 8 with a little bit after. There we go, put a decimal of a penny. So if we want that in pounds, then we'll leave that as it is. And it's already told us that that is 1 litre. Now that's ideal. So 1 litre is £1 and 8 with that little 9 after it. If it was higher than that, if it told us something like 5 litres, then of course we could divide that by 5 or whatever it was to get down to 1 litre. But this has already given us 1 litre, which is ideal. So the second one has given it to us in dollars. So we want to convert this into pounds. Now you can see in our exchange rate here, the dollar number is bigger than the pound number. So we need to divide by 1.46 to turn this into pounds. We're just going to do that on the calculator. So 2.83 divided by 1.46. And that comes out as, and it's a very, very long decimal, but we have 1.938356164, and the 3 and the 4 have a recurring pattern. There we go, so all the way from the 3 to the 4 is recurring. Now we're not going to need to worry too much because we are only comparing the value, so we just want to know which is better value. Now also, we've been told that this is 1 gallon. So if we want to turn that into litres, what we've been told here that 1 gallon is 3.785 litres. Now we want to compare this as 1 litre. So we have 3.785
litres, which is equal to this £1.93 with the 8356164 number, which I am just going to leave on my calculator because that's really awkward to have to type back in. Now I want to know the value, not for 3.785 litres, but I want to know the value of 1 litre. So to get there, I just need to divide by 3.785, and that's going to tell me the value of 1 litre. I'll just do the same to the other side as well. So if we do that, we have the big long decimal there divided by 3.785, and that comes out as 0.512115235. Now ultimately we don't need to write all those decimals because it was £1.08 in London, and in New York it's only, and if we round it, 51 pence. So in terms of where it's better value, we would say New York is better value. I won't write down all the words there. We'll just say New York is better value, and obviously we have our working out that shows that 1 litre in London is £1.08 and 1 litre in New York is 51 pence. And there we go, there's looking at some exchange rates and some unit conversions. Now this next question is looking at pressure, and we are given the pressure is equal to force divided by area formula. It says a box in the shape of a cuboid is placed on a horizontal floor. It doesn't give us a picture of that, but we can sort of imagine what that looks like. We have a cuboid, there we go, and that is on a horizontal floor, and there is our cuboid. It says the box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per metre squared on the floor. The face in contact with the floor is a rectangle of length 1.2, let's label that, and width of x. So we don't know what the width is. Work out the value of x. Now, if we can figure out what the area of that rectangle is, then we can figure out the missing length. So let's have a look at what we've got. Now, we have the pressure at the start of our formula, and we've been told the pressure is 187.5. So that is equal to the force, which is 180, divided by the area. So we'll put the area just below. So we need to figure out what number we have to divide into 180 to get 187.5. Now, when we have things like this, these can just be switched over. Now, there is a process to that. You multiply the area to the other side. Let's call the area A, and then you would divide 187.5 back to the other side. But you can get away with this quite quickly just by switching them. So A is equal to 180 divided by 187.5. So if we type that into our calculator, 180 divided by 187.5, that comes out as 0.96. There we go. So 0.96 is the area, and it's in metres, so that's metre squared. So the area of the base of this rectangle here is 0.96 metres squared. We want to know the width. Well, length times width is the area for a rectangle, so 1.2 multiplied by x is equal to 0.96. To find the value of 1x, which is what we want to know, we just need to divide by 1.2. So divide both sides by 1.2, and we will have our width, and that comes out as 0.8. And there we go, that is the width of the rectangle, 0.8 metres. And there we go, there is some reverse pressure to find the area. So moving on to some speed, distance and time. It says here Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Now it's completely up to you what method you use here. You can use a non-calculator method, or we can use a calculator method. As we have a calculator, we'll use a calculator method here, but you can always check out the non-calculator methods, which I'll link in the description as well. So we have speed, distance and time, and we have in each scenario here a speed and a time, so we can work out a distance. So if we want to work out distance, we just do speed multiplied by time. The only thing we need to be careful of is that we write both of these in hours, which is just writing them as a fraction over 60, so 15 over 60, which is 1/4 of an hour, and 40 is
40 over 60. So you don't need to simplify those, you can just leave them as fractions out of 60. That's going to make it easier for us. So in the first part of this, Jessica runs for 15 minutes at an average speed of 6. So 6 multiplied by the time, which is 15 over 60. There we go, and that's going to give us her distance for that first part, and we'll just type that into the calculator, 15 over 60, and that comes out as 1.5. So she runs 1.5, we were looking at miles, so I'll write miles with that, so I recognise that it's a distance. Now in the second part, she runs for 40 minutes at an average speed of 9 miles an hour. So that's 9 as the speed, times 40 over 60, and again we'll just type that into the calculator, times 40 over 60, and that comes out as 6 miles. So in total, she has run 7.5 miles. Now it says here, if Amy takes 45 minutes to run the same total distance that Jessica runs, work out Amy's average speed. So we need to do a formula again, because this time we are working out speed. So speed, distance and time, we are working out a speed, so we need to do distance divided by time. Again, we have 45 minutes, which is 45 out of 60, if we write that in hours again. And then we can use that formula to get our final answer. So the distance we already know is 7.5, and we need to divide that by the time, which is 45 over 60. And if we type that into our calculator, 7.5 divided by 45 over 60, that gives us a final answer of 10. So it says here, work out Amy's average speed. Well, she is going 10 miles per hour. And there we go, it wanted us to give our answer in miles per hour, and the reason that we were converting everything into fractions there was because it wanted the answer in miles per hour. So there we go, we've got our answer in miles per hour, and there is our speed, distance and time question. Now, when we have density, mass and volume mixtures, I like to lay it out in a particular way. But it says here the density of ethanol is 1.09, the density of propylene is 0.97, and then it says 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. Now the formula for density is that density is equal to mass divided by volume, and again we can use a formula triangle. So here we have lots of information. We've got lots of things getting mixed together. When we have this scenario, I like to draw it in a two-way table, just to keep everything really organised and clear as to what we have and what we're looking for. So we'll have a density, a mass and a volume for each thing. We have the ethanol, we have the propylene, and then we have the antifreeze. And there we go, I'm going to write the antifreeze there. And let's see what we've got. We have the density of ethanol, 1.09. We have the density of propylene, 0.97. We can't add those together because we don't know the exact ratios that are being mixed, so that's what we're going to kind of work out. We have a volume given to us, that's what the litres are, and sometimes litres will be given to us in centimetres cubed. But here we have a litre being 60 litres for the ethanol and 128 litres for the propylene, and in total that makes 188 litres. So there we go. Overall, that is all the information that we have been given. Now we want to actually work out the mass of each. So here we have a mass that we can work out. We just need to cover up the mass and do density times volume. Now you'll notice in this question that part of it is in centimetres cubed and part of it is in litres. Now it's fine for us to keep the answers in litres here because we're going to keep it all in proportion, and as long as we keep all of our numbers the same, well actually once we come to work out the density anyway, it's going to stay in that same proportion. So it's absolutely fine for us to leave this in litres and not worry about the fact that those are different units, but quite a unique scenario in this question. For working out the mass though, we are going to do this multiplication, so I'm going to write my working out to the side for this first one, which is 60 multiplied by 1.09. So 60 times 1.09, there we go, and that comes out as, when we multiply them together, 65.4. So that is 65.4. I can then work out the mass of the propylene, just here, by doing the volume 128 times 0.97. So 128 times 0.97. There we go, and that's going to give me the mass of the propylene, and that comes out as 124.16. Now we can add the masses together. If they're being combined, then their overall mass is just adding them together. So our total mass is 189.56. And then again, looking at our density formula, density is equal to mass divided by volume. So to find the density, we'll do the mass divided by the volume, and that's going to finish this off, which is 189.56 divided by the 188. We'll just type that in on the calculator, and that gives us a final answer here, which comes out as 1.00829. There's a lot of decimals here, but it does want my answer to 2 decimal places. So if we chop it after the 0, that is going to round to 2 decimal places as 1.01, and that'll be in grams per centimetre cubed. And there we go, there is our density question where we had a mixture. Okay, so for this question we have some functions. It says here the functions f and g are such that the function of f is 3x minus 1 and the function of g is x squared plus 4. And to start with, it wants us to find the inverse function of f. Now when finding the inverse function, I use a particular approach. I write the function as y equals, so y equals 3x minus 1, and to find the inverse function, we just want to rearrange it so x is the subject. To do that, I want to add 1 to both sides, and that would give me y plus 1 is equal to 3x. From there, I've only got one more step, which is dividing by 3, so a nice rearranging formula question. We have y plus 1 divided by 3 is equal to x. Now, typically inverse functions questions on your dotted line will say f minus 1 of x is equal to, and then dot, 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 and you've just got to write the function in there. Now, the function that we've worked out is just here. However, we swapped the function of x with that letter y. So in the final step, you just have to swap the y back with the letter x. So it'll just be x plus 1 instead of y plus 1 divided by 3. And there is our inverse function. Now, part B of this question is trickier. It says, given that fgx is equal to 2gfx, show that 15x squared minus 12x minus 1 is equal to 0. Now, by saying show that and then giving us that equation there, all it wants us to do is find what fgx is, find what 2 lots of gfx is, and then just set them equal to each other. And in this one, they've rearranged it so that there's 0 on the right-hand side. So if we start by finding fgx, now fgx is when you substitute g into f. So subbing g into f, the way I do it is I put a bracket around the g function and around the x, and I just put it in place. So that'll be 3 lots of x squared plus 4, and then minus 1 at the end. And we need to expand and simplify that. So we may as well do that first. So we have 3x squared plus 12, and then minus 1, and that'll equal 3x squared plus 11. So there is my function fgx. Now for the next one, I need to do gfx, and I need to multiply it by 2. So let's do that one to the side. So gfx I'll do first before I do 2gfx. So this particular one, we are now putting f into g. That's a little bit more tricky because in g, the x is being squared, so we need to put this function in, and it's going to be squared. So we have there 3x minus 1, the f function, and that's being squared, and then we are adding 4. So I need to expand the double bracket. You can do that to the side. However, it's just 2 brackets, so 3x times 3x is 9x squared. 3x times the negative 1 would be minus 3x. Minus 1 times 3x is another 3x, minus 3x. And then minus 1 times minus 1 is plus 1, and we have the plus 4 at the end. Now I've done that without writing it down, but of course to the side, just write down 3x minus 1, 3x minus 1, and just expand and simplify it.
Now if I simplify what we've got there, we have 9x squared. The two negative 3x's, we have minus 6x in total. And plus 1 and plus 4 makes plus 5. So there we go. That is my function g f x. Now we want 2g f x. So 2g f x just means multiplying it by 2. So if we times what we have there by 2, let's just write times 2 here, we get 18x squared minus 12x plus 10. Now at this point we're almost done. You can kind of see that we're going to get those pieces that it said to show that. Because in one of them we have an 18x squared, the other we have 3x squared. Well, the difference between them is 15. So if we set these equal to each other, it doesn't matter which way we put them, but let's put them in the way the questions put them. So we have 3x squared plus 11, which is the fgx, is equal to the 2gfx, so 18x squared, minus 12x plus 10. Now, although they've got the 0 on the right, it doesn't actually matter what side we get the 0. It only really matters when we have an inequality involved. When it's an equal sign, it doesn't matter either way. So I want to minus 3x squared and minus 11, and I'll put those underneath the appropriate pieces here, so minus 3x squared and minus 11 from the 10, and that would give us 0 equals, we get the 15x squared we were looking for, minus 12x isn't changing, and 10 take away 11 is minus 1. So we get all the matching pieces there. All I really need to do at this point is just write it in the way they've written it, so 15x squared minus 12x minus 1 equals 0. And there we go, I have shown that 15x squared minus 12x minus 1 is equal to 0 by doing those composite functions. So we had an inverse function in part A, relatively nice one, and we had these composite functions in part B there, and quite tricky ones because we had both variations of the composite function, and we had that 2gfx, which is also a little bit rarer when it does appear. So 2gfx, just finding gfx and timesing by 2. And there we go, there's some functions. Now this next question is looking at some iterations, but this one is in context. So rather than just having an algebraic iteration, we have a real life scenario. It says the number of rabbits on a farm at the end of the month n is p with a little n. The number of rabbits at the end of the next month is given by, and then we have our iteration formula. So p with the n plus 1 means the next iteration, or the next number in that sequence, is equal to 1.2 times the current number in the sequence, or the current number of rabbits, as n is equal to the number of rabbits, take away 50. So it says at the end of March, there are 200 rabbits on a farm. Work out how many rabbits there will be on the farm at the end of June. So we have the end of March, we then have April, we then have May, and we then have June. And this is referring to the end of the month. So each iteration that we do, the first one, we'll find out how many are at the end of April, then we'll find out how many at the end of May, and then we'll find out how many at the end of June. And we just need to write them all down carefully, and we start with 200. So to get April, we're just going to type into our calculator, and I'll write down the first one here, 1.2 multiplied by 200, as it's 1.2 lots of p with the little n there, and then subtract 50. And we can type that all in one go on the calculator. So 1.2 times 200, and then subtract 50. And that gives us 190. Now what I can do for the next one, to save myself a bit of time, I can replace this 200 with the answer button. So I'll then have 1.2 times my previous answer, and then subtract 50. And if I go into my calculator, using my left button, delete the 200, add the answer button, press equals again, I get 178. The good thing about this, as I'm having to do it another time, I can just press equals again, and it will give me my answer. And this time it comes out as 163.6, and that is almost our final answer. Now the problem is, of course, we can't have 163.6 rabbits, but this means it has gone down below the 164. Now in this type of question, we could give the answer 163, we could give the answer 164. But technically, we should
round this in one of two ways, and we could make the argument for either case. Now, it's not quite gone down to the 163rd rabbit, so we could say, actually, there's 164. Or we could say that actually it has gone past that 164th rabbit, and therefore the answer is 163. Now, I'm just going to write 163 here, because typically, when this sort of question comes up, it does actually allow either answer. But we could make arguments either way for the reason why we're rounding it the way we are. But there we go. That's a real-life iteration, and it's more the process there than worrying too much about how we're going to round that final answer. But it's a real-life scenario here, so we should be at least giving a whole number for this type of question, and recognising that we can't have a decimal amount of rabbits. But there we go, there is our iterations in context. There's a lot of words in this question, but the actual maths is quite short to do. There are lots of different methods for this question, but I'm going to show you one method thinking about proportion. It says here, Sylvia wants to find an estimate for the number of birds in a reserve. On Monday, she catches 90 of the birds. She puts a ring on each of the birds and returns them to the reserve. On Tuesday, she catches 120 of the birds, and she finds that 20 of the birds have rings on them. Work out an estimate for the total number of birds in the reserve. Now, this is all just about writing down the proportion as a fraction for each of these captures. So on Monday, she catches 90 of the birds and puts a ring on them. Now, that is 90 out of the total population, which is, of course, what we're looking for, and we don't know that answer. So that's 90 out of something. The second time she does the capture, and we have the rings on the birds, there are 20 birds that have the rings on them. So that's 20 out of, and she caught 120 birds. So that's 20 out of 120. Now, when we're looking at this question, all we actually want to do is put an equal sign between them and assume that these are proportional. Now, if they are proportional, we just need to think about how to create that fraction, 90 over something, as an equivalent fraction to 20 over 120. Now, there are a few different things you can do. If you can spot without a calculator how to get from 20 to 90, brilliant. But you might be able to simplify this fraction on the right, and actually it does simplify. You can divide the top and bottom by 2. You can divide by other numbers as well, but if we divide by 2, we get 10 over 60, and that's a really nice number to think about how it turns into 90. So if I write it again over to here, let's have a think. We'd have 90 on the top. How do we get from 10 to 90? Well, that's just timesing by 9. We do the same to the bottom as we're creating an equivalent fraction. We're just going to times by 9, and we need to work that out. So you might want to do 60 times 9. So 6 times 9 is 54. So 6 times 90, or 9 times 60, would be 540. So there we go. So that's 90 out of 540. Now that x on the bottom, that 540 on the bottom, is what we are estimating to be the total number of birds in this reserve. So our final answer is 540. We are making some assumptions in this question, and it does say in this part here, Sylvia assumes that none of the rings have fallen off between Monday and Tuesday. And that's one of the assumptions we make in this question. There are more assumptions that we make than that, but we assume that the rings haven't fallen off. We assume that none of the birds have died. We assume no additional birds were added into this reserve. So they're all things that we assume because all of those things could affect our answer. But it says here in part B, if Sylvia's assumption is wrong, explain what effect this would have on your answer to part A. Well, if she is wrong, and we might want to write that, if she is wrong, okay, if she is wrong, and we're specifically referring to the answer here, as it says, what effect would it have on your answer? We would say the answer could be higher or lower. And that's absolutely fine for us to just say the answer could be higher or lower. The important part there is for us to say it could be either. If the rings have fallen off, for example, that would be different to if more birds had been added to the reserve, or if some of the birds had flown away or mysteriously died in this particular scenario. That could all affect our answer in different ways. We don't know which one it is, but in this case here, where none of the rings have fallen off, well, if they have fallen off or if they haven't, we could have some different answers. Now, in this scenario, it is actually an interesting one because it does say this particular assumption. It says the assumption here is that none of the rings have fallen off. Now, if she is wrong and some of the rings have fallen off,
Well, actually, it does affect our answer in one particular way, so we need to consider that with this question. Now, let's imagine in a scenario where the rings have fallen off. And let's just imagine that actually 30 of the birds were supposed to have rings on. Now, that would change our answer, because if it was 30 out of 120 instead, and we were trying to get to 90, well, in that scenario, we would only multiply by 3. And in that scenario, the total would be 360. So in this one assumption, which is a very unique question, actually our answer couldn't be higher or lower. If she's wrong and some of them have fallen off, then our answer could only be lower. So in this scenario here, I'm going to change that answer ever so slightly, just because it's different to sort of the usual question. If she is wrong, the answer could be lower. And I'm going to stick with that lower one for this one, because we've just proved an example there to show that it could be lower. Okay, so in this question, we're looking at angles in parallel lines. Now, it says here that A to E, DBG and CF are parallel. D to A, D to B and D to C are all the same length, and we are shown that anyway because it gives us these additional lines on these triangles here, which straight away is telling us that they are isosceles triangles. It says that EAB is equal to BCF, which is also equal to 38. Work out the size of angle X, and you must show your working. So, for starters, there are sort of two sets of parallel lines put together in this one. And above and below this central line, they are identical. We know they're identical because we have that 38 above and below. But we want to have a look between two of the parallel lines to start with. We want to see if there's a connecting line that goes between the two, or we can find any alternate, corresponding or co-interior angles. Now the first thing that stands out to me is that we can make this nice Z shape which hooks in this 38 and gives us an alternate angle just up there. So this also has to be 38. Now it doesn't tell us to give reasons in this question, but here the reason that that is 38 is because alternate angles are equal. And in a lot of questions, it does ask you to give the reasons. We don't need to in this one, but just so you know, along our working out, that's why it's 38. Now we can almost now come away from all of this image, and we're going to now look at and sort of zoom in on this triangle here, because we've already said that's an isosceles triangle because two lines are the same length. On an isosceles triangle, base angles are equal. So this here is 38 as well. And although we're not giving the reason, we have base angles in an isosceles are equal. And that comes up quite a lot. So there we go. Base angles in an isosceles are equal. We can now find the top angle within the triangle. So this one just here. Because angles in a triangle add up to 180. So we can do 180. And again, it does say you must show your working. Take away, and then we have the two 38s, so 38 plus 38, you could work that out and then take it away from 180. I'm just going to type it all in one go, so 180, take away 38 plus 38 in brackets, and that gives us 104 degrees. So that one there is 104. Now, it's not always going to be like this, but because that is almost reflected up to the top, in other words, all of the angles above are exactly the same because it's the same diagram, just sort of flipped upside down on top. That means this here is also 104. So to find that angle X, that is the missing angle around a point. Angles around a point add up to 360. So to find our final angle here, we would do 360, the angles around a point, subtract the two 104s, so 104 plus 104, and there we go, we can type that in, 360, take away 104 plus 104, and that gives us 152 degrees as our final answer. And there we go, and if you wanted to write a reason along with that, it's because angles around a point add up to 360 degrees. And there we go, there were some angles in parallel lines and also involving some isosceles triangles. Okay, so this question is looking at a cylinder. It says here, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 and height 160. The 4 tanks are going to be filled completely with a mixture of fertiliser and water. The fertiliser has to be mixed with water in a ratio 1 to 100 by volume. Karina has 32 litres of fertiliser. And it tells us here that 1 litre is equal to 1,000 centimetre cubed. Has Karina enough fertiliser for the 4 tanks? You must show how you get your answer. Well, for starters, we need to actually work out the volume of one of these cylinders. So the volume of a cylinder is the same as any other prism. You get the area of the cross-section and times it by the height. Now the area of the cross-section here is a circle, so we need to get the area of this circle. To do that, we want to know what the radius is. The radius is half of the diameter, so that's going to be 40 centimetres, and then we're going to use our formula pi r squared. Once we've done that, we'll times it by the height, and that's the volume of the cylinder. So if we work that out, that's going to be pi times 40 squared, and we can either type that in and then times by 160, or we can just times by 160 straight away. And let's just write that down then. So pi times 40 squared times 160, and that gives us a very large volume here, but we get 804,247.7193. And there we go, that is the volume of one tank, 804,247.7193 centimetres cubed. Now it says here that we are going to have 4 tanks. Well, she has 4 tanks, so we need to multiply this by 4. That's going to give us the volume of all 4. So if we press times 4 on the calculator, we're starting to get to some very large numbers now. That's absolutely fine though, just make sure we write them all down. So we have 321,6990.877. So that's 3.2 million centimetre cubed. Right, so we're getting some very large numbers. Now, it says here, Karina has 32 litres of fertiliser, and it's going to be mixed in the ratio with water 1 to 100. So we're going to need to work out exactly how much volume we have here, but that's given to us in litres, and we're currently working in centimetre cubed. So completely up to you. You could either convert the 32 litres into centimetre cubed and keep dealing with very large numbers, or we could turn this volume now into litres, and we can do that just by dividing by 1,000, as it's 1 litre for 1,000 centimetre cubed. So if we divide that by 1,000, at least we're going to get some slightly smaller numbers. So here in litres now, the 4 tanks is 3,216.990877, and that's now in litres. So that's how much space is in those 4 tanks. We just now need to work out exactly how much space we actually need. So the fertiliser is to be mixed with water in the ratio 1 to 100. So the fertiliser to the water is 1 to 100. Karina has 32 litres of fertiliser. So she has 32 litres, so we need to multiply by 32, which means we're going to have 3,200 litres of water. And the total there, if we add those two together, is 3,232 litres. So, has Karina enough fertiliser for the 4 tanks? Well, it does say the 4 tanks are to be filled completely with the mixture, so they have to be completely full. Well, Karina has 3,232 litres, and space-wise, she has 3,216 litres. So she has more fertiliser than she needs to fill the tanks. Only a little bit extra, but that does mean, yes, she is going to be able to fill the tanks. So we would say yes, and you could write next to that, she will be able to fill the tanks. You can write any sort of explanation you want with it, because she has 3,232 litres and the tanks are only 3,216. So she is going to be able to fill them. And there we go. That was a functional volume question dealing with cylinders and having a little bit of ratios in there. Okay, so in this question we're looking at some frustums. Now a frustum is made by removing a small cone from a large cone, and that is actually what we're told in the start of this question as well. You can see that in the diagram. But it says here the frustum is made from glass, and the glass has a density of 2.5 grams per centimetre cubed. Work out the mass of the frustum and give your answer to an appropriate degree of accuracy. That last line is quite interesting as well. An appropriate degree of accuracy. That means we sort of have an option of how we want to round it. So something like 1 decimal place maybe.
So looking at this question then, can we get the volume of the frustum? Ultimately, it wants us to work out the mass. So we need to think about our density formula again. So we have density is equal to mass divided by volume. To get the mass, we need to do the density multiplied by the volume. We are given the density, so we'll just need to do 2.5 multiplied by whatever the volume is. So we'll leave that there and we'll come back to it. So getting the volume of this, I need to work out the volume of the frustum. We are given the volume of a cone formula, so I just need to work this out. To get the frustum, I need to get the volume of the large cone that used to exist before the top was sliced off it, and then we'll take away the small cone that was chopped off. So here we're going to do the large cone, and it's always good to label it, so I'll label it large and small. So that would be 1/3 times by pi. The radius here for the large cone would be half of 12, so that's 6. So times 6 squared. And the height of that large cone would have been 15. So there we go. I'll type that into the calculator. 1/3 times by pi times by 6 squared times by 15. And I'm going to leave this in terms of pi, because if I start writing down lots of decimals, there's a lot to write down, and as it's come out in terms of pi, it's much easier for me to leave it like that. So 180 pi. I'm now going to look at the small cone, the one that's been chopped off the top. But the small cone does take a little bit more thought process. Now we can see the total was 15 and this little height is 10, so the height of the little cone is relatively nice to find. That's got a height of 5. Now finding the radius of that cone, we need to think about what proportion of the large cone has actually been taken off there. And it's 5 out of 15. So this little cone, looking at the height, is 5 out of 15. And that is equal to 1/3. So it's 1/3 of the size in terms of proportion. So we're going to have 1/3 of the radius. So 6 divided by 3 to find a third gives us a radius of 2. So now we can find the small cone. So it's 1/3 times pi. The radius is 2, so times 2 squared times the height of the small cone, which is 5. Again, I'm just going to type that into the calculator. I've already got my old calculations there, so I'm just going to delete the 6, change it for a 2, and then delete the 15 and turn it into a 5. And there you go. It doesn't give us as nice a number writing in terms of pi. It gives us 20/3 pi, but that's still easier to write down than the 20.94395,102 that I'd have to write down otherwise. So there we go, that is the small cone. So to find the volume of the frustum, which is the whole goal here, because then we just have to times it by 2.5, I just need to do the 180 pi, the large cone, take away this 20/3 pi, which is the small cone, and if we work that out, 180 pi, subtract the smaller one, we get 520/3 pi. You could at this point write it as a decimal if you want. The decimal is quite a large one. It's 544.5427266. I'm going to have to write that again because I've got to now times it by 2.5. So I'm just going to stick with using this 520/3 pi. Just feel like that's easier to write down. So 520/3 pi that we're going to times by 2.5, as that was our density, and we're doing density times volume. So times by 2.5, and that comes out as now a final answer. Now it does come out in terms of pi. However, it says to give your answer as a suitable degree of accuracy. So I'm going to write it now definitely down as the decimal version. So we get 1361.356817. Now, a suitable degree of accuracy means we're likely not going to give that to 5 decimal places. So it would be absolutely fine to sort of round this to, well, we could round it to 1,361. That would be suitable. You could have 0.4 at the end. You could even round it to 1,360 and have it to the nearest 10. It's actually fine for us to round it in lots of different ways. But there we go. I'm going to leave it as 1361. That was, of course, a mass, and we were dealing with grams. So that's 1,361 grams. But again, I think you'd be allowed anything between 1,360 and 1,360 2, you know, in terms of how you've rounded it. So there we go, 1361 is our final answer. Now our next question is looking at a circle theorem. It says here ABDE is a cyclic quadrilateral. Well, great, because opposite angles in a cyclic quadrilateral add up to 180. ABC and EDC are straight lines. That's helpful because straight away we can see what this angle next to the 60 is, because that makes a straight line. It says given that the size of EAB to the size of BCD is 2 to 1, work out the size of BCD. And you must show your working. Right, let's just find this angle on the straight line, then I'm going to come back to that ratio. So this one on the straight line here, they've got to add up to 180, so that is 120 degrees. Right, let's go back to this ratio. EAB to BCD is 2 to 1. Let's highlight those. So EAB is up here, and BCD is over here. Now, if they are in the ratio 2 to 1, I would normally label that either using algebra or keep it as a ratio. I'm going to label it as algebra. I'm going to call it 2x and 1x, just so I remember I've dealt with that. Now, let's see if there are any other angles that we can find. So straight away, opposite this 120, opposite angles in a cyclic quadrilateral add up to 180, so that would be 60 degrees. Now, I've got to figure out where to go from here. So we have a large triangle. If we have a look, I'll highlight this large triangle here. And we know angles in a triangle add up to 180 degrees. So now that we've written those two angles in terms of algebra, we can actually form an equation. We have 2x plus 1x plus the 60, and we know that all of those combined have to equal 180 degrees. If we simplify that, we get 3x plus 60 is equal to 180. We can then take away 60 from both sides, so 3x is equal to 120, and then we can divide by 3, so 1x is equal to 40. So now we know that x is equal to 40, we can actually substitute that into the two angles. This one over here would be 40, and this one up here would be 80. And from there we can actually go ahead and work out some of the other angles as well. But this question says to work out the size of angle BCD, which was this one over here, where the 40 is. So our final answer is 40, and there we go, actually we've written that down here. So we'll just keep that 40 there as our final answer. And there we go, there was looking at some circle theorems. That one only focusing really on cyclic quadrilateral and the opposite angles being 180. Of course, there's lots of circle theorems that you need to look at, so I'll link the video in the description for this one for all the different types of circle theorems. Now for this question, we have some algebraic iterations. Now there are three parts to this. Part A here says show that the equation x cubed plus x is equal to 7 has a solution between 1 and 2. Now knowing the word solution here, that means a number which goes into this equation which gives us the answer 7. So there is a number that if we cube it and add that number to the x cubed, we get the answer 7. Now, if we substitute the 1 and the 2 in, we should find that actually we know there's going to be an answer between those. So if I start with x is equal to 1, and I would write my working out down for this just by subbing it in and writing 1 cubed plus 1 and saying what that's equal to. Now 1 cubed is 1 plus 1 is 2, and of course you can type that in your calculator. If we then use x equals 2, well that's 2 cubed but plus 2. 2 cubed is 8, plus 2 is 10. Now if we look, you can see that 2 is below 7 and 10 is above 7. And that means there must be some number in between 1 and 2 that gives us the answer 7. So we could write a little conclusion. You could say something along the lines of 7 is between 2 and 10. There we go, and that would be fine to give your description just like that, and just showing that that answer at the end, whatever that may be, is between those two numbers. For part B, it says show that the equation x cubed plus x equals 7 can be arranged or rearranged to give x is equal to the cube root of 7 minus x. Now typically with this sort of question, there is like 1, 2 or 3 movements to get that equation into the form it's asking. Now the first step you can normally see by looking at the equation. You can see here that the 7 has got x being subtracted away from it. So that means the first step of rearrangement here would be to take away x.
And if we do that, we get x cubed is equal to 7 minus x. And that's the first step. And showing that really clearly and how we've got it is really important, as it does want us to show that this can be done. And the next step is a bit of a strange one, because the only other thing missing now is the cubed root that we have in the equation here. Everything else is on that right hand side. So in order to do the cubed root, we need to cube root both sides. I could sort of show a cubed root over the top of both, like this, or you could sort of just do your next piece to the side. However, it feels a bit strange doing this next step because we are essentially just writing down exactly what the question has given to us, and that final step there can kind of feel that you're not really showing much, you're kind of just writing down what the question has told you to show. And that's absolutely fine. If that is the next step, there's not really much more you can do to actually show that, other than writing yourself a little essay underneath it and explaining what you've done, and that's absolutely not needed. Typically you only get 1 mark for these questions. So it is only a little bit of working out, and it's really important that you show that middle step. So the final part here says starting with x0 equals 2, use the iteration formula, and then we have our formula there, similar to our one in context. It says to get the next number, you do the cube root of 7 minus the current number, and it's asking us to start with 2. Do it 3 times to find an estimate to this solution. Now again, really nice because we can do this in the calculator. So to find x1, we're going to use the number 2. So we just do the cube root of 7 take away 2. And if we type that into our calculator, and of course this does rely on you being able to find your cube root, we get an answer, and it comes out as quite a long decimal, 1.70997. Now I've not got much space on the screen, but you should write down the full number for these solutions. Now on the next solution, I don't need to write that number back into the calculation. I do want to show my working out here, because I want to show really clearly that I know what I'm doing. But the next step, I'm just going to do 7 minus the answer, which is exactly what I'm going to type into my calculator. I'm going to go in, I'm going to delete the 2, press my answer button, and I get my next solution, which is 1.74241. And again, there's more decimals, but I don't have enough space to write it down, so we're just going to leave it there. For our final solution, because I already have the answer button in my calculator, I can actually just press equals 1 more time. And again, I'm just going to write down this stage of working out where I just write 7 minus the answer. And I get my final solution now, which is 1.7388. And I get 495, but I'm just going to write up to the 4 there. And I'm just going to write those little dots. So obviously when you're doing an iteration, do write down the full solution. Unless, of course, it says in the question to write down the full answer, and just having an awareness that these are only estimates to the solution, because we can keep pressing our equals button there until eventually it gets very, very close to one of our solutions, or actually stops on one of the solutions. But when we just do 1, 2, and 3 like this, it's very rare that we'd actually get to our solution in just 3 jumps, and that's why we're only doing an estimate. But there we go, you can also see that the 1.73 is also between the 1 and the 2, which it was asking us to show in part A. So it's all kind of linked together as well, which is quite nice. But there we go, there is an iterations question. Now for plans and elevations, this particular one is asking us to draw a side elevation, and that's from the direction of the arrow. So this shows the front elevation and it shows the plan. So the plan is from above and the front is from one of those directions. Now you can kind of, and you don't need to draw this, but you can kind of imagine what this shape looks like. Obviously I sort of am okay at drawing this. I wouldn't necessarily expect people to draw this diagram, but it can help just to sort of visualize it in terms of what it looks like, and it's almost like a staircase. So that's what this particular shape is. It's not asking us to draw a sketch of it, but you can see now from the plan, you can see this sort of part where there's 4 there, which is on the top here. We've got this next part, which is just there, and then this little step is this bit here. So that's what we can kind of see from above. Now, that makes it a lot easier when you can sketch it, but you don't need to sketch it, because if we are going to draw a side elevation, we know from the side it's going to be the same height as the front elevation. So I can actually just draw in the height, making sure it matches the front elevation. Now we can see here from this particular side that we're looking at it, that is this particular length just there. And you can see that's 2 squares along. So from the side, we would see those 2 squares. and then it would just be a rectangle. So it's the same height as the front elevation. We've got our rectangle drawn. The only thing that I need to add in to my side elevation here is every time there's a little change of height, we just need to add in an extra line at those 2 points. So I would add in an extra line here and also an extra line there. And there we go, that is our side elevation. So it does help drawing those just next to a front elevation. It does really help if you can visualise these. I wouldn't expect everyone to necessarily be able to visualise them and just draw a sketch just like that. Particularly with this one, it's a relatively complex shape, but there we go, there is a question on plans and elevations. Okay, so this question is looking at bounds with compound measures. Now these questions can be pretty lengthy and they can be a little bit painful to work out because there's just so much to write down in terms of the quantity of numbers that we need to write down. So here it says we're trying to find the density of a block of wood, and the block of wood is in the shape of a cuboid. We have the length, the width and the height, and they've all been rounded to the nearest millimetre. He measures the mass as 1970, and that's correct to the nearest 5 grams. And then it says by considering bounds. Now unfortunately, when we have to consider bounds, it does mean we need to do the upper and the lower bound, which is what makes this question quite a lengthy one. But it says work out the density of the wood and give your answer to a suitable degree of accuracy. And you must show what you're working. Now for starters, if we are looking at the density, we need to think about our density formula. And density is equal to mass over volume, whether you use a formula triangle or not. That is our formula. So to work out the density, we're going to need to do the mass divided by the volume. Now when considering bounds, we need to work out the upper bound and the lower bound. And to do the upper bound, that means we need to do the biggest mass, so the upper bound of the mass, divided by the lower bound of the volume. For the lower bound, we're going to need to do the lowest possible mass, so the lower bound of the mass, divided by the upper bound of the volume. And I'm just going to write here density is equal to mass over volume. So we have a lot to work out because there are lots of numbers here and each one of them we need to write an error interval for. So for the first one we have our error interval will be 13.15 and that is, I'm just going to use x, in fact I'll use the letter L for the length, and that is going to be 13.25. For the width we have 16.0. Now that's going to go down to 15.95, and that is the width, and that'll be 16.05. For the height, we have 21.7, so 21.65, that's the height, and 21.75. So there are the error intervals for each of the lengths of the cuboid. Now if we're going to need to work out the volume of the cuboid, remember to work out the volume of a cuboid, you do the length, let's call that this one, times the width times the height. So the volume is going to be length times width times height. We also have a mass down here which is correct to the nearest 5 grams. Now if it's correct to the nearest 5 grams, that means we have to add 2.5 and subtract 2.5 grams from that number to get our bounds. So that'll be 1967.5 for the lower bound. I'm going to use m in the middle for the mass, and that's going to be 1972.5 for our upper bound. Now, we're very close to being able to complete this, but I just need to get the volume of the cuboid, and I need the upper bound for the volume, or the largest possible volume, and I need the lower bound for the volume, or the smallest possible volume. Now to get the largest possible volume, I want to multiply these three numbers together. And rather than writing out an absolute ton of things here, I'm just going to multiply those together on the calculator. So we have 13.25 times 16.05 times 21.75. And of course, that gives me a very large number. I get 4,625.409375. For the lower bound, again, we're going to get a large number, but I need to multiply these three together. And for the lower bound, we have 13.15 times 15.95 times 21.65. That gives us as a lower bound for the volume
4,540.925125. And there we go, that's my lower bound. And on the right here, we have our upper bound. So we have all the numbers that we need, and we've already written down to find the upper bound of the density. We'll take the upper bound of the mass, divide it by the lower bound of the volume. And for the lower bound, we'll take the lower bound of the mass and divide it by the upper bound of the volume. So over here, I have my lower bound on the left and my upper bound on the right. So I'm going to write in the actual calculations that I'm going to do. So for the upper bound, and you can kind of split this up if you want, there's a lot of working out to write down. I'm trying to minimize it as much as possible. For the upper bound, we want the upper bound of the mass, so 1,972.5. And we want to divide that by the smallest possible volume, which is 4,540.925125. For the lower bound, we'll take the lower bound of the mass, so 1,967.5, and we're going to divide that by the highest possible volume, the upper bound, which is 4,625.409375. Alright, so a little bit awkward, but we're going to type it all in. So for the first one, 1972.5 over that volume there, and that gives us 0.434382, and there are more decimals, but I'm going to stop there, and I would write down the full decimal normally, but I don't think it's going to go beyond this many decimal places, so I'm taking a bit of a gamble here because I'm now going to type the other one in, which is 1967.5 over 4625.409375. And that comes out as 0.425367, and a few more decimals, but I can already see it's not going to go into that many decimal places. Now here it says give your answer to a suitable degree of accuracy. Now a suitable degree of accuracy typically is as relatively close to sort of 1 or 2 decimal places as we can get. But in this instance, where it says a suitable degree of accuracy, we're actually looking for a point at which these two numbers round to the same thing. Now that normally doesn't tend to go beyond 3 decimal places. Doesn't mean it can't, but if you look at these numbers to 3 decimal places, my number on the left would be 0.434, and my number on the right would be 0.425. So of course, very different numbers. To 2 decimal places, my number on the left would be 0.43. If we round this to 2 decimal places, 0.43. And my number on the right would also be 0.43, as it's a 5 after the 2. So that would be 0.43 as well. Now I have a match. And of course, you could round them to 1 decimal place, which would be 0.4. But we're trying to give it as accurate as possible. And although it doesn't say that, give your answer as accurate as possible, that's what it means by a suitable degree of accuracy. So we're going to try and give it as accurate as possible. So here my answer would be 0.43, and it does say give a reason for your final answer. So next to my reason, I would just write that they round the same to 2 decimal places. And of course you could describe that in terms of significant figures as well, but decimal places is a relatively nice, easy and quick one to write down there. But there we go, that is using some bounds with compound measures. Now most compound measures either involve a division or a multiplication, so you need to just think very carefully which one you are being asked and know your formulas very well. The hardest type of questions typically will involve a division, where you have to use this process of the upper bound divided by the lower bound for the biggest possible number, and for the lowest possible number using that lower bound over the upper bound. So that was a question there that involved absolutely everything, and of course involved a bit of volume there with the cuboid as well. But there we go, there was a bounds and compound measures question. Okay, so here is another question looking at further trigonometry. So these questions here do tend to have lots of variations in terms of the trigonometry that's needed, so you need to know your cosine rule and the sine rule very, very well, including the rearrangements for finding angles. Now this question says it shows a triangle ABC, and it gives us some measurements on the diagram and in the description. It says D is the point on BC such that the size of angle DAC is 2/5 of the size of angle BCA. So this angle here, if we were to work that out, well, this angle over here is 2/5 of that. So to get that angle, we would find out the angle x and then times it by 2/5, or divide by 5 and times by 2. It says calculate the length of D to C, which is this length here, and give your answer correct to 3 significant figures, and you must show all your working. Now this is a relatively complex question, because it kind of looks like this is just two shapes put together. But actually, it creates this triangle ABC, and it tells us that in the first line. The diagram shows triangle ABC. And ABC is the full triangle here. And actually, if we look at it as a full triangle, we can actually find the size of angle x, because that's opposite the 3.4, and we have the other two side lengths, meaning that we can use the cosine rule. Now, if we were to use the cosine rule to work that out, well, this would be our angle A, and this would be little a, and then we have B and C. Of course, if you just use the one variation of the cosine rule. Now, the cosine rule, if we kind of draw it small up here, is a squared is equal to b squared plus c squared minus 2 bc cos A. Now, we need to work out an angle, so I need it to be cos A equals. Now, if I do that, now I do it in one step. I add the 2bc cos A to the other side and subtract the a squared. So I end up with 2bc cos A is equal to b squared plus c squared minus a squared. I can then divide by 2bc and I get my formula cos A is equal to b squared plus c squared minus a squared all over 2bc. Now it's up to you if you learn whether to rearrange it or whether you just learn the formula outright. Doesn't really matter either way. But now I can actually work this out. So for cos A, I would need to do b squared plus c squared, which is 6.1 squared plus 6.2 squared minus 3.4 squared, and that's all over 2 times b, which is 6.1, times c, which is 6.2. Now it's completely up to you how you do this. I like to just do the inverse of cos when I'm finding the angle, and then put that entire fraction inside the bracket. So it does it all in one step. Or you can type it all in one go and then just do cos minus 1 of your answer. Now when you do that, if we type that in, we get 32.0804, there's quite a lot of decimals here, 6913. 08046913. Perfect. And that is the size of angle x. And we can label that on the diagram. I'm just going to label it as 32. Now, we already figured out that to find 2/5 of that would give us the other angle. So if I do that answer, 32.08046913 multiplied by 2/5, or of course you could divide by 5 and times by 2, that gives us this angle over here, which is 12.83, and a few more decimals, but I'm going to stop there. Now, I need to look at this triangle again, and I need to get rid of this 2/5, because it wants me to work out the length of D to C. And now we're kind of able to look at this smaller triangle on the inside. Now, to find the length of DC, I would ideally use the sine rule, because I do have this pair of opposites. And the pair of opposites that we are looking at here, we have the side now opposite this 12.83, and we have another angle which we can find opposite this 6.2. We don't have the length of A to D, but we can very easily find this angle here because it's a small triangle, and we've got two of the angles within the triangle. So if we do 12.83, add the 32.08 and subtract that from 180, it'll tell us that missing angle, and then we can use the sine rule, as we will have two pairs of opposites, and that's the rule that we need, or the situation that we need, in order to use the sine rule. So I'm going to do 180, subtract my previous answer, plus the 32.08046913, and that gives me an angle up here of 135.0873432. There's a lot of decimals there. Now, it wants my answer correct to 3 significant figures, so I could probably do my working out to 4 or 5, and that would be fine. I would still probably not get a rounding error, but I think it's safe just to write all the decimals down. Now, for the final step, we will use the sine rule. So we will use A over sine A is equal to B over sine B. And if you want, you can now rearrange the letters that you wrote down and sort of label these up however you want. So I've got the A here, so I'll keep that as A. And this can be my little a that we're working out. And I've already got C on that one, so you could either label it as C or I could change that to B for this part, and this is my big B. So my sine rule for a side length is A over sine A is equal to B over sine B. So I want to put the pieces in place. So I have A, which we don't know, over sine 12.83 is equal to B, which we have 6.2 over sine, and then we have that 135.087. And I'll keep that to 3 decimal places in my working out so it doesn't get too messy. Now I only have one step of rearrangement to get A on its own, and that's to multiply this sine 12.83 over to the other side, and that'll just go up here onto the numerator. I'll have sine 12.83. So I just want to rewrite that nice and neat, as that's going to be my final step of working out. So A is equal to 6.2 sine 12.83 over sine of 135.087. And if we type that into our calculator, let's see what we get. So 6.2, hopefully you've written the full numbers down for this, so you can type the full number back in, just to make sure you don't get any rounding errors, or at least a good few decimal places beyond what we have been asked to round our final answer to. And there we go. For me, this comes out as 1.95, and then actually there's quite a lot of zeros after that, and a few more decimals at the end. But it wants it to 3 significant figures, and there we go. After the 5 would be my 3rd significant figure, and this would round to 1.95. And there we go, that's my final answer. It does want it as a length, so that is a centimetre. So 1.95 centimetres would be my final answer. Now hopefully you've got your revision under control and you are making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.